research assholes sure fucked you up.
I know what's going on. We got a bunch of fucking vampires out there trying to get in here and suck our fucking blood. And that's it, plain and simple. I don't want to hear anything about I don't believe in vampires. Because I don't fucking believe in vampires. But I believe in my own two eyes, and what I saw is fucking vampires. Now, do we all agree that what we are dealing with is vampires?
All right, we are finally live. Sorry about that, everyone. Tonight we have Frankie with us, who has patiently been waiting to show us some of his coils, the Rodin coils, star coils that he's been making, as well as we're going to go over some the Earth grid energies and how that affects stuff, and the whole coil concept. And we are joined with Jeremiah. JP joined the technicians, our coil expert, as well as Can't Be Defeated, and I believe Adam also was on the Alien Scientist channel, I believe. Jeremiah, Frankie, do you want to take it away a little bit and show the coils and your idea of what you're going with that we're talking about right before we went live there? I think you're muted, Frankie.
Sorry about that.
There we go.
Okay. Give me a sec.
For those that don't know what a Rodin coil is, or vortex-based coils, the PoE coil, the star coils, they're these electromagnetic hyperdimensional induction coils based off of vortex-based geometry and mathematics.
Yep. No, 1 second.
All right. In the meantime, do we got any questions? Can't Be Defeated, Adam, Jeremiah?
I guess I'll just make sure audio is working. I can see it is. That's good. Yeah, Adam has got quite a bit of experience building coils, and he's also built some Greener style coils and had some both tragic and very interesting results.
Oh, yes. I am looking forward to this.
Well, we should probably get an audio check on him, because I'm not
Adam,
sure
are you
he's
there?
got his microphone configured right yet. So you might want to check that, Adam.
It looks like I'm not muted.
Oh, we can hear you.
Yeah, we can hear you.
You're quiet, but we can hear you.
Okay, well, I know where the microphone is on the phone. It's plugged into the wall, and it's anyway. I'm likely not to go dead. Hopefully. Anyway, so yeah, I've seen some very odd things of. Anyway, the machine I built a long time ago, it on average time flowed just fine, but with digital and analog clocks, because remember you used to be able to go buy mechanical clocks. That's something that I suppose isn't really a thing anymore. Anyway, they both clicked off time not linearly, like they'd be plus or minus 3 seconds, but it was anyway. It's one of those weird things that should have never happened. Something's really wrong with mainstream physics because of the machine that I've seen in front of me. But I suppose it's like the bagel coil field stuff. Of course I built that because that made the same field as what I had built a long time ago. I was all expecting that to work because I had seen it before. And I still have a scar on the side of my own because I made one of these fields at about 7.2 megahertz in the 40 what is that, the 40 meter band? My gosh, I'm sorry. It's really late at night here and I can't remember anything. Anyway, it floated around my place about 3 days before it burnt the heck out of me. It hit the inside, the other one hit the inside of my mouth and gave me a giant, I don't know what you'd call that. And then the other one just hit me and it gave me, I was tired for a couple of weeks. I'm pretty sure I was really lucky that none of this stuff hit me in the eye and I recovered from all of this stuff. The bagel coil field, once you make that field, it can be almost completely undetectable because I had a shortwave radio that I pushed around the room and looked for this. I couldn't see it at all after I made it, but it still found me a couple of days later and burnt the hell out of me. These things are entirely unsafe to be playing with. So that's my experience with that stuff. Anyway, I think that's probably Bob Greener might be right that it's like all of what our reality is made out of, what all the quarks are made out of, but that means they have to be made out of the correct frequency and size in order to interact with reality. And obviously, me building one of these coils at 7.2 megahertz, a couple of inches across, was not what our reality is normally used to. And it just kind of floats around till it hits something and all that power dissipates. And I put 100 watts in with a shortwave transmitter, and it came back to hit me. The ones I made at 60 cycles a second with the same coil, they also came back and hit me. I felt them, but they didn't leave scars. I just felt them. They kind of, I could obviously feel them, but they didn't hurt me at all. So anyway, I'm not sure this stuff is very safe to be playing with.
Yeah, see, I'm glad you bring that up, Adam. And like I've done and built a lot of different coils designs over like the years, but I've yet to start hooking them up to the signal generators in the machines and like pulsing them, testing them, and putting them waves and energies through them yet until I fully know what I was like doing and incorporating with it. And that putting like the Schumann resonance and like the 432 hertz and some of the solfeggios are a good way, like the I think 369, 936, and 639, specifically out of the solfeggios, and testing like these harmonic energies first so that it's and the Schumann resonance, especially at like those frequencies that, so if you're creating these big fields, that the chances are it's going to be something that's more harmonious and like healthier of a field to interact with, as opposed to something that could like shock you, drain you, or like harm you in other ways. Is that kind of your experience with it?
So, for those of you who may not be familiar with the work of Bob Greener or the Martin Fletcher Memorial Project, or even the work of Ken Childers, what we're talking about here is a coil of wire, which, when driven with a sufficient amount of power, it produces a really, really strange state of matter called an electron cluster. So normally, like charges repel and opposite charges attract. That's at least what we're all taught. But when a charge is in motion, it has a wake field behind it. If you accelerate an electron in a straight line, it'll actually have a positive field behind it because it's being pulled away from the point where it was sitting. And so another electron that was in that area will try to chase it to fall into that more positive region since it's already been polarized. Well, turns out that with a certain coil configuration and the right amount of energy, you can get electrons to strip themselves right out of the atmosphere and cluster together in a nice little Ouroboros loop where they will be cycling as a closed loop really, really fast. And the amount of energy that they can contain depends entirely on how many electrons they can eat. If they happen to come in contact with your skin once they're clustered together, or your body, well, they're going to get their electrons from wherever they need, and that would unfortunately be your epidermis. Or in his case, even in the inside of the mouth. But yeah, so electrons do weird things when you slam them with high power fields, and they can start to loop together and actually kind of stick to each other without any proton or other positive charge in that equation whatsoever.
It's a extremely advanced electrical engineering and physics. But for those also just making, before you go on there, Jeremiah, Frankie, do you want to just hold up your coil that you had there and explain how you were bending it up as you envisioned with how light reflects with the coil? And you gotta unmute again, Frankie.
It's more polite that way. Sorry. I need a few minutes to reflect. Sorry, this is the first time I've ever tried to do this. Give me just a minute, please.
No worries. Jeremiah, do you want to like explain the coils a little more, or should I like show some of Bob Baker's specific design is entailing?
It would be great if you could show at least an image of what those clustered electrons look like when they're cycling. Nothing tells it like a picture.
Man.
Sorry, wrong one.
This was my first attempt at a studio.
All good.
It's kind of embarrassing, but whatever.
Sorry, I gotta load the box. So Jeremiah, like which like image did you want me to show specifically towards what you're describing?
Well, I would show the physical bagel coil. Just show one of those things so we can kind of get an idea what Adam's been talking about, the stuff that he's been playing with.
Where you're
very similar, yeah, very similar. So you've got coils of coils.
Exactly. You got a toroid around a toroid around a toroid. So it's 3 electromagnetic fields that you're creating within themselves when you run a current through the copper toroid or torus. Oh, we got Adam back.
There we go. We got video. Awesome.
Adam's got some video. You can, if Adam is able to share the coils we're talking about.
I was trying to get video of my coils, and apparently I accidentally disconnected myself trying to seek the correct camera. Because this phone has 5 cameras built in.
Yeah, oh, there we go. Now we can see it perfect. If you turn your phone sideways, it will give a full.
That makes
I'm
me feel so
looking.
much better.
I'm looking for my flashlight. I just found it.
Perfect. No worries. No worries. We're working it out as we go.
Well, you're a
But-
tenth of the volume you were a moment ago. Anyway, here's, I don't know, my coil winding apparatus. I've got machine shop equipment everywhere around here. My 3D printer. I've got a lime tree, and anyway, I'm not sure that's helpful.
Oh,
but what
very
I'm
helpful.
looking for,
Actually, can you focus in and show your the coil windings a little bit more? Oh, perfect. There we go. Those right there are the 2 spec Bob Greenyer coil designs, correct?
right? So this one that's got the 3 red drinking straws out of it, that one is hopefully center field there. It's that one is, I think, left configuration, and that's the one that I put 100 watts of radio frequency energy into it, and it burnt the heck out of me. This is left, that one is not very useful. And then this one here is,
there we go.
What?
Sorry, you broke up for a second, but now we can see and hear you clearly again.
Okay. I wonder how to get more audio out of this, because I've turned up my audio.
The sound was good. It was just glitching a little bit for the second there, and I think it was as you got closer to the coils, they actually emit a frequency interruption with the Wi-Fi or the signal. I usually have similar problems.
I hope not. It's 4G.
You might be right, Bernie.
Yes,
I wonder if that's what's going on.
About a foot or two, Adam, as you describe it, we'll probably be able to hear you better, but we can see it perfectly, and your sound is good.
Well, the only problem right is you are like a little whisper.
Closer to it, it cuts out, but when you're a couple feet away, we get the signal back.
Well, that's odd. Anyway, this one
it's my own.
Wait, hold on, I left all of it. So this one here, that's iron wire. I never got anything useful out of this thing ever. But anyway, the iron wire bagel coil, I'm not sure is useful, but this one's useful, and this one is the one that burnt the heck out of me. But so winding them opposite polarity like this one here, I'm not sure is a good plan. Anyway, those are the coils I made in that realm. I've got other stuff.
Nice. So Bob Greenyer states that he suggests a iron core as the smallest or the first wire or wrap that you start wrapping, then the outer copper coils around. So your inner wire first is the ferrite, and then you put 2 copper wire layers around that wrapping, and then wrapping in the configuration that he suggests. The one that I have is copper on copper on copper, and then I had also done one that it's copper on copper, and then it's iron ferrite on the outside. So I don't think I'm going to probably ever put energies through them until I know what I'm doing, and doing them in the specific ways that are safe and healthy as mentioned, and that the counterclockwise, I've always wrapped my coils to the left too, and I got it when whether you believe there's anything valid in Keshi technology or not, Keshi taught to wrap his coil solenoids to the left to counterclockwise triple as well, and then Bob Greenyer simultaneously states to do it. So I suspect there is something in regards to the current and the toroids going counterclockwise for better effects.
My logic in this is that I have spent an enormous amount of time in my friend's vitamin store, and there's a fair amount of vitamins that they sell
like, L-glutamine or something, and you look at it and it's all like left-hand spin, and I was thinking about this going, huh, that's interesting. Like, why do they care so much? And anyway, it looks like most of the life we know of has this left-hand spin to it, and I think it's left-hand spin as it goes away from you. So I
Yeah,
know if
but
it's left.
the right hand rule of like regular electromagnetics and engineering, and then like the way the universe, like the moon, the earth, the sun, and the center of the galaxy are all spinning, it's like you're going counterclockwise, so you're going against it and then somehow getting counter space energy or something, like somehow some way. But it seems to be just so many synchronicities in different esoteric ways, and also the understanding of the toroidal universe.
Oh, I completely agree. You set yourself up for the wrong direction, and good things are not going to happen to you. It's like the difference between glucose and dextrose. They're opposite spins of each other. There's the same chemical, but they're opposite spins, and one of them is food for you. The other one is, well, it's something else.
Exactly, right? It's the building or the deterioration, like just the duality of the universe, and that there's certain geometries and energies and ways that energy transfers through dimensions and through the universe, and just a matter of figuring it out.
So,
Frankie,
my
you ready to just show your coils there? Have anything to say, or Jeremiah, anything
I
to
do.
interject?
I do. I would like to take things in a different direction. Maybe that's not a good idea.
Just a note, plastic is actually a higher conductor than iron. So don't throw plastic out completely as your centerpiece for your coil.
Right. That's a good point as well, Adam. And the electrostatic and energy of it, and the different ways of collecting and using the interacting electromagnetic fields and materials.
Yes, each has a
Simple question.
different hertz rate, and the more hertz rate of a natural vibration or the natural resonant frequency that the object likes to resonate at, normally, the more closer the number amounts are to each other, like 450 to 432, the more conductive they will be than more further vibration rates of other materials that are a little more far off in magnitude. So plastic actually has a certain vibration rate to it, a Hertzian rate of natural resonance. So this was done by John Keeley, and you all know about his information, and he was able to actually space objects together in a pressurized jar, and by just using amount ratios of the pressurization or the gas, managed to make objects like float just by analyzing the vibration hertz rate alone or similarly. And they, by Casimir effect, which is just the attraction or repulsion of the fields of the object's vibrations, just that alone, and not using any power injection from any electrical source or anything, just in the natural resonant frequency of the objects alone, they were able to push off each other in repulsion, and they actually floated. I would have to find a video on it. Somebody actually managed to pull it off. So.
Very valid. Very valid. And yeah, so there's a question about is that why electrical wire is coated in plastic? And it's interesting too how electricity moves. There's been a lot of different YouTubers doing experiments showing that electricity essentially is moving at like the speed of light, that it's not actually moving within the mass of the copper itself on the inside, but on the field outside. And then the dielectric insulators and different interactions of how different wires are wound and coated, and also that it makes more sense in my further understandings of what Keshi taught with what they call nanocoating, where you break down the outer physical layers of the wire coils. And in theory, he says it's that by breaking those covalent bonds to the structures of the inner copper metal, and then just having one atom bonds left on the outside, thus the nanostructure as it's broken down. So Ohm's law, you're inversely affecting the part of it, but it's that it actually exponentially increases once you're able to interact with the plasma state in the monoatomics or superconducting material and plasma energy fields, and then putting it into the third dimensional physical metal copper element and wire loop system. And at first I was extremely skeptical of Keshi's claims and whatnot, but the more that I'm learning about it, the more it's all coming together. It's making a lot more sense. And especially when looking at the ancient technologies, Antiquitech in history, and the nanotechnology of the past, and especially like geopolymers and the plasma, or what I understand is this plasma state monoatomic matter and nanotechnology incorporated into it. And for those that have no idea what I'm talking about, I'm going to be doing an interview with Dutch Synths, the legendary Dutch Synths YouTube channel, and Paul Cook channels coming up on this geopolymer mixes and all of that.
There should be an intro for people who have never, there should be a kindergartner like explanation.
Yeah, this is absolute some high advanced stuff we're going over, but that's all good. We're all figuring it out as we go, and that's what asking questions is all about. And there's never a stupid question. Earlier before we went live, though, Frankie, you had your star coils that you were making, these Rodin coils, and you had a structured in a pyramidal manner, the star coil foiled into itself like a pyramid. And you were saying that your thought process behind it is creating like the way light moves and shapes and splits off with these signals. And I think that's actually an absolutely ingenious concept. So if you want to show it off and elaborate it a little bit more.
The thing is, I'm like so picky about how it looks, and I got like
science is ugly, man. There's a lot, like, don't worry about it. Just it's like look at this fucking beast of a thing of just wrapped coils together that, like, my God, if you put a current through it, it would probably just start on fire. It's in such disarray. But that's beside the point.
So right now I'm basically going to mount this.
So first off, what type of copper wire are you using? What gauge, and how many rounds are there in those star coils?
It's the 16. This is basically the biggest extension cord I could get from Home Depot. And there's 3 wires. They're big ass wires.
Gotcha.
Right? And it's exactly a Rodin coil, but it's a star coil. I wrapped it around this thing. So it's basically gonna look like, I guess it's hard to show. I'm sorry about that. I wasn't ready
to. Pretty good perspective of it.
I have several more if you want me to show you.
For sure.
I have 3 of these. I'm trying to figure out which ones to use that's better.
That's what it's all about, right? And Adam, while we got you, do you want to explain a little bit more like what you're using when you hooked up these energies and put different energies through it?
So, yeah, I can describe what happened. Basically, it appeared to me as if, anyway, sometime in the, I don't know what you'd call it, early to mid 1990s, I built this little device, and it's wait, where's the right lighting? Anyway, it's basically a Wimhurst machine with a bunch of segments on it, and these segments I didn't know enough that they are made out of steel, and like a low carbon steel. I set it up as a Wimhurst machine to begin with, and they did really weird stuff. Like the clock ticked off time incorrectly. And I built this thing, like you can literally pick this whole thing up and toss it across the room because it's so solidly built. I don't know. I guess I did this a long time ago. Like there's no good reason for any Wimhurst machine to ever be built like that. But anyway, it did
I
really
like that. And the fact you're saying it affected the clocks, Mike if you've seen Mike with Faraday Research Channel, I do a lot of streams and work with. He says when he built and tested his N machine, that he had similar sort of effects off of the kitchen clock and whatnot when he had it running a few times, and on his cell phone and whatnot. They were all like off by like different amounts and stuff each time he turned them on.
Well, I suppose what struck me about this one is that the time clicked off randomly. But then again, after I shut it off, it went back to, anyway, I built, anyway, does anyone remember Nuts and Bolts magazine from the 1980s?
Yes, sir.
I built a ghost detector, of which I'd love the schematic. This thing that is center view here, I built it in 1994. I guess December, but I don't know when the magazine article was published. Anyway, it's a differential amplifier with an insane amount of amplification and between the two different antennas. And I've always wondered, like, what is the schematic? Because I lost the magazine article. Anyway, but what strikes me about this stuff is that this was something that's not supposed to happen, and standard physics, like, they were annoyed at me. I remember building this device and talking with my physics professors when I went to college, and they told me this thing should never be built. They didn't say you had the wrong interpretation or something else. They told me it should never be built, which I think is hilarious because, I mean, come on, you tell somebody, like, you shouldn't have done this.
Right?
That's not how science works.
You're creating portal energy fields essentially, and this is absolute key to understanding the UAPs and like time dimensions and how it all works, and like how energy comes out of these Wilhurst machines. Like I am so stoked at seeing what you got going there, and like.
Right. So this is 50 segments, and if I had to rebuild it, I would do 48 because of what brought
48. Yes, 100%. You got to tune it to 48.
Right. This is 50, and for some reason, when I built 48, and it's apparently close enough. And Bob Greenyer tells me 51 is the maximum limit. 48 is probably ideal. So.
48 is key, and it has to do with specific ratios and alternating magnetic fields. You want 24 and 24 north-south, essentially. And what I'm talking about is Ed Leeds-Scallan's flywheel and several others that I've seen, and that essentially you're creating a similar sort of machine and design, and that we should be looking to essentially connect both of them together.
Right. So this thing, when I first ran it, I had a belt. By the way, the belt I'm running is it's automotive vacuum tubing because it's stiff enough to actually, be a decent belt. I've got it over 2 motors, and then the other side of the belt, I ran across a pulley. You can see there. I don't know, maybe not. Anyway, so when I spin this whole thing, they spin exactly opposite of each other. They're completely counteropposed. Now, this was really important when I first ran the machine. Now, after I ran it a while like that, I went and I changed it to a different configuration, and it still added energy into the field, and that worked just fine. But that whole locking between the two different directions there, that was really important for it to start. And that's the big problem I have right now is I can't start it again. Like, it's not running like it used to a bunch of years ago. And I find this fascinating because it really doesn't turn like it used to. And I'm not getting this bagel coil field, but I can still wind the bagel coil field and I can pour energy into that and it does the same thing. So whatever I did before, this thing isn't running like that. And whatever, like a bunch of these things, they need conditioning or starting or whatever it is. Jeremiah can say probably a lot more of that. He's seen a bunch of this stuff. But this thing doesn't run like it used to because I got lucky when it first started years ago, and I can't reproduce that. And do you know how annoying it is that I can see an effect and see a clock tick off 3 seconds in a blink of an eye, and then I can't reproduce my own work? So frustrating.
For sure, right? And it's like sometimes it's like you got to just leave it alone and take what you did learn off of it and apply it into the next project or the next idea. And let's
not this time, man. He's definitely going to get that machine working again.
Oh,
one way or the
100%.
other.
We need a version 2 of those, and I'm already thinking of like how Mike should be putting like that onto his Adams motor design flywheel, and incorporating more different advanced what the hell are those generators called again?
Are you looking for Wimhurst machine?
Well, yeah, Wilhurst machine. Sorry, the Wilhurst generators.
By the way,
incorporating that into advanced flywheels and atom like DC motors and stuff like that.
The only reason why this thing really worked the way it did was I took a standard Wimhurst machine and I decided I wanted one plate positive and the other side negative. So most of them have a shorting bar on both sides, so that half of the disc is positive and half is negative. I wanted one disc positive and one disc negative, so I pulled off half of the shorting bars, and that's what made this thing work really strange and mess with gravity and time and all the rest of the stuff it did. That was the real trick to it. They had to be completely matched and even, and that was the weird thing that they did that I'm pretty sure nothing should have done.
Yeah, the synchronization is an absolute key here because you have your scalar potentials, and now you're rotating those scalar potentials. They're all dot product, or basically you have a bunch of tiny little charges that are all stuck to the surface of these plates. And it turns out the plates that you used, since you built it so wrong after all, the plates you used were magnetic. And normally you'd use copper or aluminum, non-ferrous materials for your Wimhurst machine, but you just used galvanized steel flashing because it's what you had. And hey, what difference does it make anyways, right? It's conductive plates. And as a result, got a really fascinating effect.
Jeremiah, what about using like those ceramic plates that do you know which ones I'm talking about? Like the dielectric ceramic supercapacitor plates or whatever the heck they are, like the ceramic magnet plates as the disc that you would build that on.
Well, here's the thing, Bernie. The interesting part about Adam's The Curious Device creation is that it developed its own magnetic fields. There was no magnetic field injected into that system at any point. There were no permanent magnets except for those which were in the motor, but they didn't really have much of a contribution. What's interesting is if you take electrons and you shift them around within the mass of a metal, especially a ferromagnetic metal, its ferromagnetic properties are affected, and it can self-generate or spontaneously create external magnetic fields simply by moving the charges around on it. And he had a system where the magnetic field intensity that built up between those two disks was quite intense, enough to disrupt electronics and make other people in the room feel quite uncomfortable, and apparently enough to affect the clock rates of both a mechanical and a digital watch that were placed close to that thing. So it's self-generated. You don't need magnets. Those discs that on his machine, they're acrylic, just, basic plexiglass.
Right. The thing that got me the most when I was running this is that I tried to detect the magnetic field with a compass, and it would rewrite the magnetic field in the compass the other direction. The magnetic fields out of this thing were insanely high, enough to literally rewrite a magnet near it just instantly. I've never seen anything like it. Like I've got other magnetic hardware. Like one of these things that I've got is remember Radio Shack has they have those demagnetizers for the audio and the videotape things.
Yeah.
Anyway, this thing was clearly thousands of times more powerful than that. It was the most powerful thing I think I've ever even seen as far as the magnetic field. You get a couple of foot away with the Earth's magnetic field and the Earth wins versus any magnet you've ever seen. But this device I played with, it was something else, that's for sure. The fields were incredibly high out of it. And the thing that got me the most about it was I ran it once in an empty room, and then I picked it up and I walked out of the room, and I went back 15, 20 minutes later, and the compass is still just spinning a circle in the middle of the room. And that was something to see. Anyway, it's that whole rotating.
The experiences you're telling me are bringing back memories of Nassim Haramein lectures where he's described very similar sort of test experiences himself with some of his designs, and I'm just loving the synchronicities.
Well, you know who else has a system of counter-rotating disks that happen to possess their own self-generated magnetic fields? Alexei Churikov, Gravity Flyer.
Right, exactly, and that's why it's like tomorrow night. It's Jeremiah. You best be there as well. I got Charlie Crawford III, and we're going to be on a Leak Project promoting APEC, and Charlie talking his Alexei Gravifier designs, and I would love to have you there and run some more ideas by him because I see potential in it. I think that it's Alexei's do you think Alexei is legit like that with the right adjustments that it works?
I think the original videos, and this is actually partially based on conversations that Adam and I have had. Yeah, we kind of came to the same conclusion. His original videos have a few flaws. I'm not sure if they're true. His later videos, I can't find problems with 3 of them, and I know enough about how to pull stuff off, and have seen enough magic shows and whatnot to identify where you could possibly put suspension points. There are 3 videos he has which are very, very difficult to debunk. But more importantly than whether or not Alexei actually did what he showed himself doing, or was a trick, those same fundamental principles he's trying to talk about, they do apply. And they have a very, very wide sweeping range across many studies and have been reported similar effects for over 70 years now. So there's got to be a parallel there. If nothing else, he's a great researcher for finding all those nice keywords and telling the right story. But honestly, yeah, could you build a device that looked like the Graviflyer and did in fact fly? Absolutely.
Right? Like that's how I suspect and feel the exact same towards that. I'm like loving that. And we gotta test Mercury, and like how are Jeremiah, are you in your lab? Do you have your like mercury available to
I
like?
don't keep that here, not at all.
Okay, yeah, no,
The
yeah,
amount that I have, I don't keep anywhere near me, or even more than 4 feet above the ground. And so it's in a totally different facility.
fair enough. Exactly, and that is key. Everybody, safety and precautions. Like you can easily kill yourself in so many ways with all of these different energies, metals, and chemicals, and all of that. That you have to be smart about it, or you will die. So don't try it at home. But just the fact of there needs to be more experiments with mercury, and I suspect rotating it at extremely high RPM while in a charged state, whether putting voltage through it while rotating it at a high RPM or in a contained like vacuum field chamber
Yeah. If you
rotating it.
rotate the mercury in a vacuum environment so you don't get oxides forming on the surface, one of the major problems with this high friction coefficient that mercury has on surfaces can be overcome. Mercury doesn't have it doesn't really have this tendency to stick to much of anything it doesn't amalgamate. So if it's just on plastic, it'll roll right off. If it's on glass, it'll roll right off. It's not going to absorb into those materials. But there's a catch. Whenever you physically perturb mercury, whether you stir it, pour it, or just let a bead of it roll across the surface, it is such an active conductor, such a highly self-ionizing fluid that it'll form electric field bonds and stick to the surface because of electrostatic potentials. It's similar to a triboelectric effect where you rub fur on a glass rod and you'll end up developing a charge on the glass rod and the fur will take off the other charge. Well, mercury does that just on its own anytime you have it sitting against any other surface that's basically not mercury, and it'll form these partial electric field bonds which cause it to drag. In a high vacuum environment, you can eliminate most of that, but you can't really get rid of it all. So it's best to put it through a magnetic field to help cause all those ionic charges to move along in the right direction, and it will self-generate an electric field. You don't need to put that in. It'll make that all on its own.
Like just sorry, mercury, it's so fascinating and like so crazy. And I was just thinking back of like the Paul Cook mercury rectifier videos and the research he's done on it, and then I brought up this little clip here. I don't know how much of it is real or how like accurate, but the legendary red mercury. So I'll play this quickly and let me know what you think of this, Jeremiah. Like
Adam has a few things to say about that too, but go ahead and show people what the alleged folklore is.
Exactly, the folklore.
By the way, if you guys didn't notice right away, both those hands are moving differently. It's not a reflection. It's two different hands.
That's why they also call it vampire blood. Because it doesn't reflect in a mirror. It's scared of garlic and attracted to gold.
Why garlic?
Yeah, I don't know, but I think it's something to do with the acids in it. It must be.
Is the substance illegal?
Well, you know, it would be
Oh,
great
yeah,
is,
pretty
if
much.
any of these videos are real.
Like plutonium
If you
kind of
found
stuff.
with it, yeah, they'll
Yeah,
at
it's
least take it off you if they don't throw you in jail.
extremely illegal in Russia and the former Soviet Union.
Well, like I said, it'd be great if that red mercury formulation they're claiming they have was actually real, but no, turns out it's not. So there is such a thing as
we've tested that chemical compound that was shown on there because I wrote it down and I wanted to ask you about
the
that.
SB204 based one. Yeah, antimony mercury compound.
I'm kind of surprised the magnet pulled the mercury at all.
It didn't. But
It didn't?
I can show you guys how every single one of those scenes in that video is fake.
Yeah, so it's all fake stuff in your opinion?
Well, there is. I want to touch on what the real red mercury is. There's a red state of mercury, and it happens as a byproduct of a high vacuum environment and mercury having a very high velocity against the edge or boundary layer of an insulator. So it turns out that in a low vacuum environment, or just basically as much as a cheap Harbor Freight vacuum pump can pull, if you stir mercury around inside of an evacuated glass vial, and it still contains a lot of atmospheric gases, it'll glow purple and blue on the surface. It'll glow blue against the surface of the glass, and it'll glow purple over the entire surface facing inside of the glass, because it generates about 300 volts at the minimum to about maybe 1,200 volts or more, just because you're basically stirring it by hand. It lights up on its own. You don't need to add any power. It's capacity. So when you increase the vacuum environment to a very, very high degree and you inject an electrical charge so that you have a different quantity of free valence electrons existing inside there, and you have a different quantity of molten electrons, the mercury will produce a red glow at the interface surface between the glass and itself as it's stirred. And this only happens under very high vacuum conditions. But yeah, the whole entire stuff will be glowing red. The whole vessel will. So it's red state, but it's not the magical formula we've seen online.
So where I'm interested is that whether this turns out just to be a copper compound or if it's actually a mercury compound and was a transmutation in the copper electrolysis. It's that I've been able to turn metals into what the ancient alchemists, including Isaac Newton, state as the mercury state of metals, and that it's I need to get this tested to see if that is actually mercury compound with the copper, or I need to just be able to start doing my electrolysis in a controlled lab safely with actual mercury, because I'm pretty sure I would be able to get mercury into a red state like I've gotten all the other metals into the red state that is supposedly this transmutational but mercury state, or plasma mercury state.
So you see what Adam's showing there? He had this little vial of mercury, this little glass vial that he collected, and it's kind of gone away now, but since I don't know if we have audio on him, I'll just describe what he said to me as he's showing you the video image. That vial of mercury formed a red substance that was floating on the surface for years. And you can still see just a little bit of a red tinge as he lights it up.
I believe that and love, and that is why I need to get some mercury to experiment with, because just the alchemy electrolysis stuff, and what the ancients write about it seems so much more advanced, and pretty sure I can create this red in a cold energy. And see, look at that.
Actually, you can see the red. Yeah, just a bit. It's not strong anymore. But
once again, though, notice how it's wavy. His camera's getting wavy. That I've discovered anytime you're getting into a plasma field of some sort, your video and picture will always get this wavy sort of feed and interference happening.
Hey, Adam, is that what kind of flashlight source is that? Is that a modulated flashlight? Like it has semiconductors in it, or is that just plain old LED and like resistors?
Oh, it came from grocery outlet for $6. It's one of my favorite flashlights. Let me find another one that's probably not modulated.
Yeah, I still think those lines that we're seeing are.
Also the modulating parts too.
Yeah, remember your own all of your house lamps that run off a plug-in-the-wall adapter, Bernie. They're all going to have that same flicker issue because you're getting what they call this stroboscopic effect in propellers. What do they call that?
This one doesn't seem to have any flicker, right?
I'm not seeing it there. So with a straight DC source,
it's really weird that it shows up brown, but it used to be red, and it's kind of, I suppose, depending on the light, it's a little different. But it's absolutely pure mercury in the bottom of this thing. But it's over the years, it's gotten more and more of that brown color, kind of reddish. No, I've never opened this bottle. This was one that I met somebody at a party about 20 years ago. That was they were totally freaked out. They're back to this bottle of mercury and they didn't know what to do with it. And I'm like, I'll happily take it off your hands. So anyway, that's how I got this. Which I don't know if that's fair game or whatever, but I've never taken the top of it off or tossed it anywhere else. But you can see at the bottom, it still looks like mercury. Oops. But the whole now this weird brown color you see red.
yeah, the natural oxide of mercury is not red. Just in case anybody's wondering, is it just oxidizing? No, the natural oxide of mercury is a dark gray. It's quite ugly and patchy. Unless it's combining with some other inert or atmospheric gas, it's really a mystery as to where you could have gotten that reddish hue from. But there is the obvious answer that maybe there were oxides in it that happen to have the right nanoparticulate size to refract that color of light.
Well, it was red for a bunch of years, and it's not now, which is weird. Like it got attention somehow. It's like the opposite of a cockroach.
Yeah, that's funny.
Anyway, who else has mercury? Let's see all your mercury.
I need mercury.
What?
Yeah, and I'm not pulling out my giant old pickle jar of that stuff anytime soon. But let's just say I have enough to build a small craft.
I only got enough of any of this because of the webbot guy that figured that
Cliff High.
He thought that silver would be really valuable in the future, and I didn't want to get last out, so I bought 100 ounces of silver. It's still not worth anything, but still not worth much, I should say. But assuming there's some interesting alloy of silver to happen in the future, I don't want to get left behind. Same with mercury or any of the rest of my elements. Well, I've got a little element collection here. It's zinc and tin, and I've got a bunch of gemstones of various types. They all have different things. Germanium, that's one of the weird ones you can get in crazy high purity for like no apparently good reason. 9s with like every possible number following that.
You get a nice collection of stones there.
And then cerium. I think this is cerium. Oh no, I'm sorry. No, that's not cerium. Where's cerium? There it is. This is the thing that makes the like little sparks in the lighters that people hit. That's the thing that has the really fantastic sparks. Anyway, don't know what I'm going to do with it. And it's how I think the nail like mixes everything up to infinite degrees. Here's my bismuth, like a pound. Anyway, I hope to have all these elements because maybe one of them will be useful in the future. I'm not sure that adorable, cute little shell over the tea candle is going to be horribly useful in the future. But anyway, I don't know. I'm all for owning all of the
Loving
elements.
it, Adam. Loving it. Absolutely loving it all.
And some of them are just downright pretty. Anyway.
Adam, your video is coming through better than your audio.
Oh, well, that's fun. That'd be a first.
Right?
Anyway, it's yeah, I've got various things from I don't know what, all kinds of odd stuff. The candle program my ex-girlfriend made from, what do you call it? Anyway, I've got all kinds of stuff in the cabinets here, but most of it is the rock collection because that's what counts. My elements are in the back. I remember telling one of my friends that runs a vitamin store I've got magnesium. He's like, "What form is it?" I'm like, "No, it's metal." He didn't understand it. Anyway, it was really funny. I had to bring it to him and show him what magnesium was. It was hilarious.
You mean all magnesium doesn't come in a capsule? What? Right?
Magnesium oxide or whatever, magnesium citrate.
Oh man, there are so many dangerous forms of magnesium that are marketed as health supplements right now. It's insane.
It's just hilarious to me that it was like pure magnesium and you didn't understand it. Anyway, it's just a bunch of people, like they get ideas in their head about what happens, or like, you know, anything. Like I've got copies of the pharmaceutical book from 100 years ago where half of the formulas have mercury in them. Dear God, like, why do they do that? Anyway, it's just kind of funny, but it's, I don't know, I suppose people have different points of view at different points and different ideas about what they do, and I don't know, people's bias on the world is so important. I think most people really forget how much your bias really affects the world around you. Like, where your attention is probably where you're going to end up. And I do not want to end up in this little glass bottle because I'm pretty sure that would be horribly toxic for me.
I agree, man. Like, bang on right there. Some alchemical wisdom you are speaking.
I've got a couple of people sharing alchemical stuff with me, and the one is crazy secretive and says you can't share this with anyone ever. And the other one wants me
all
to share
of them
it with...
start like that, Adam. All of them that I've ever read. It's so crazy.
So here's one. I've got a mystery for you then, because one of them wants to share everything with me, claims he's from the Ukraine, and he lives in London. And he sent me a screenshot from a picture that I had sent him from email. And it's really clear from that screenshot he's reading all of my emails translated into Chinese.
That's
so
intense.
What the hell's going on there? How is a Ukrainian living in London reading Chinese as their default language? This doesn't make any sense, especially since he's supposed to be some learning disabled person in London.
That's some weird shit right there.
It's not normal.
Don't know what to tell you on that one. That sounds like a spook if I've ever heard of one.
Something's wrong there. Anyway, I trust the mercury a lot more, even though I'm never going to touch it, but still, like, something's wrong with that guy. I'm pretty sure.
I have a feeling I know who you're talking about.
Well, hold on. Oh wait, I can't click away from this phone call or it's going to just drop it. I've only got 21% of battery left. It's a bunch of like random keyboard pressy things for his first name, and then his last name is missing the last three.
Well, maybe it's not the same one.
It's like DJ, but I don't have any more devices on that tell me anything. I can't log into that or I'll lose. Anyway,
no.
What?
So China's trying to steal your secrets, hey Adam.
Is anyone trying to steal my secrets? Like, if they're trying to steal my secrets, I'm deeply flattered. Next of all,
you're giving them away.
If China's going to steal my secrets, I miss Lydia. She was working for the, I didn't have clearance to go into the Lawrence Berkeley labs, but she did as a Chinese national. And oh my gosh, we went out a bunch of times. I absolutely loved her. And it was just one of those things. I figured out she was a Chinese spy after she left the United States. But, who the hell do you tell about that after you realize, I'm pretty sure that was a Chinese spy, and then I saw it in the news later that that's exactly who it was, and what the hell do I do with that situation? Just nothing.
Yeah, maybe just keep quiet about it until it all blows over.
That was 20-some years ago.
Oh, you're good then.
Oh, yeah, it's blowing over by now.
That's
anyway,
definitely
so it's all blown over. It's just, I missed her, and I remember being in the middle of, I don't know how, does anyone know the store called Target?
Oh, I know the Target. It came to Canada for all of 3 months.
Oh, 3 months. Well, that was enough to figure out who they were. Anyway, they've got backup generators on all the stores over here. So this was before China had any LED flashlights. And I remember telling this girl, I'm like, I'm worried about this. When we were in Target, the last day I ever met her, it was, I'm worried about this thing. And I convinced her to spend $10 on an LED flashlight. And I still wonder what she thinks of me. I think that might have been the start of China taking over flashlights, because no one had any idea from that country. I convinced her they were a good idea. There was a power failure, the only one in 3 years, when we were literally looking at the flashlights in the aisle, and that's what convinced her to get one. And she took it back home to China the next day. And I hope I did not incite some sort of China taking over the flashlight.
You made the world a better place if you made LEDs vastly and cheaply available to everybody.
Yeah, it was inevitable, Adam. All the LEDs that were in the United States assembled flashlights were made in China anyway, so they just took it home, really.
Well, where were those chips made? Wasn't the only place they made them? In Taiwan and Texas? I don't know where they made them. Maybe Germany? Germany made a fair amount.
Yeah,
well, Germany's about to not make anything because they no longer have the energy to produce it.
Oh my gosh. So on the other side of my room here, I have got all this stuff because I'm trying to prepare for the energy apocalypse. I don't have good lighting, so that's why you can't see anything on my camera. But anyway, I swear I'm focused at a furnace that should be able to melt cast iron somewhere right in front of my camera. I'm trying to get ready for the fact that no energy is going to happen or come up with something else. It's one of those things that I've been feeling the whole idea that we need to get ready for something else a long time ago. And I heard a bunch of people all complaining that the LEDs were spying on them. I've met a bunch of really odd people in life. I'm like, build your own. So here's my build my own flashlight.
Well,
or
smart
room lighting.
Yeah, anything that's smart technology, the Internet of Things is spying on people. That's one
Right.
thing. But to
Right.
think a
So-
little diode is spying on you is a completely other.
Right,
Oh
so
no,
these-
they have nano receivers, nano-sized in paint now that they had an article on that can receive communication from any amount of spatial distance, across states, just from paint.
If you
There's an
want
article
really
on it.
weird tracking stuff, go look up lithium iodide and that whole story. That's really a really broken thing. Anyway, I've got the Q5 LEDs, 3 of them here, with a resistor wound on the back side of it. It's 34 gauge copper wire on the back of it, runs into 12 volts into my solar power system. And if you really want good, decent lighting, anyway, there's a little side switch on my light here. So I've got high and low setting. But anyway, it's just, if you want good lighting or something else, or you want electricity, just go build it. And if somebody's spying on you because you're running on some weird chip, well, then maybe that's going to happen. But
I can second that, man. 100% of the lighting in the room I'm in was built by hand by me. So it's like I wanted better lighting than the commercial garbage that was available. So I just built it.
Right. Exactly. Like if you want different things, if you think there's an LED, some RFID chip spying on you, go build an EMP device and just fry the thing, whatever. It's not that hard to do that stuff. Just build stuff, and if you think something's spying on you, take it out.
Or emit a equalized field that matches the pulsations of whatever is like a kind of like you build a Faraday cage, that could work, or the light.
Well, brute force works perfectly fine as far as destroying electronics though. So if you have some electronics in your facility that aren't supposed to be there because you didn't put them there, fry them.
Yeah, right.
So there's a couple of. Oh wait, I don't have a light right now, but anyway, I swear my camera is pointed right at my HF radio, which is capable of 100 watts. And if you start pushing 100 watts into a radio frequency field and you do that in close proximity to an RFID chip, you will blow it to pieces. And there are standard frequencies they operate on. They're not like a mystery. You just set your radio for that kind of frequency. And you can blow those chips apart just in nothing flat. It's not that hard. I know it's technically illegal to do that sort of thing without a call sign and talking with someone, which I certainly have, but for the most part, it's just not that hard to set that stuff up and blow those chips to pieces.
Absolutely, and it's not exactly difficult to restrict the field area so that it only works on devices that are really close to you that you're controlling, especially if you have kind of control over your own place. Don't do it in an apartment.
Right. Don't put your cell phone near it when you're doing it.
Yeah, well, I recently got a new banking card sent to me, to replace the expired card I had on file, and they of course sent me one of these wireless tap to pay BS cards, and if you look at the normal chip contacts, there's a gap between those contacts and then the plastic card. Shining the flashlight through it, you can see all the coils and their connections. All you got to do is slice those coil connections with a razor blade to disconnect the RF receiving functions of that chip underneath those gold plates, and you are not going to get hacked by somebody else standing next to you with an RFID reader stealing your card. I'm slicing mine out. I don't need tap to pay. There's absolutely zero reason why I need that, but unfortunately that's just the standard that people are getting set now, so it's easy enough to remove it. And you can still use your card afterwards.
What's in the upper right corner? What are you showing?
I'm just out in my outside little alchemy lab and some of my different electrolysis alchemy jars and experiments and salt batteries and all of that.
I've been studying to use any device with just a 1 watt of power, or if not, to achieve very strong fields as far as in the mercury level. I think it's just attenuating the signal better through all the noise, and just it's a method they use that's called frequency up conversion. So you scale from down to a low hertz rate. So it's say pulsation of, it could be 10 hertz or somewhere in at least 8,000, and you can try to intensify and amplify the signal more than a device could handle. But then you would have to do it slowly to where you would align the harsh pulsation away from its natural resonant frequency. You would try to get it back to where it's not harshly heating up. You try to get the heat down, and that's how you can actually scale up. You can jack the signal even higher once you align it back from the previous jack signal you did.
So you're not using any amplifiers then?
Yeah, well, it's you can it's the same concept. You are not using you're amplifying regardless the signal. You make the device work harder, but if you can have some type of scanning system or something that could, monitor the the harsh frequency peaks and stuff. You can just by trial and error frequency injection techniques or modulating techniques, like whichever be like in a digital device, like you change it to analyze analog signals only. You can actually make amplify a circuit board to operate in the terahertz range and even bypass the swinger limit with these type of techniques. But it requires lots of signal analysis type of skills and stuff. So these are like literally hands-on. Go ahead.
No, I was going to ask if you have like data results from what you've done versus how much noise you get out and what frequency spectrums you get.
No, this has had these. No, I have not done any experiments yet. I'm still a novice in this field, but I am got some books that can tell me how to do these things, and these are the same
that you
books.
have on terahertz signal generation, anything you have at all, I'm extremely interested in getting my hands on a copy of it.
Oh yeah, no, for sure. I have your email.
Terahertz is key to everything.
Oh yes,
that's why I asked.
Well, Jeremy Rise, I managed to get his book on hyper and ultra fast frequency engineering by Robert I. Sarbacher. So, that they use that same book to achieve the, UFO technology engineering techniques. It explains a lot. I'll send a copy to you, Jeremiah, and then you can.
I'd appreciate that. If you don't mind, I'll forward it over to Adam.
Yeah, and he also had an extra book of frequency modulation as well. I managed to get that one, and anything by him, I at least managed to grab. What else I got? I got I just study antenna design, antenna and theory design, and you also study, like you said, I managed to get a spin waves book. I will send that to you as PDF file.
Awesome. Since that's kind of been like the big shit that I've been going on for almost 2 months now about spin waves and the criticality of understanding spin waves and the terahertz regime, how they relate to each other.
Really,
I'll mention it here again because I mentioned it on Jeremy's show. And,
go ahead. Yeah.
Yeah, you can generate a terahertz output with a kilohertz input by grabbing onto the electron valences of atoms in molecules or in a crystalline lattice of a metal. And if you oscillate those things in just the right way at their own precessional frequency, they'll grab onto the nuclei, and when the nuclei rebound, if it's a fast enough pulse, they'll rebound into the terahertz region. So they could be anywhere from, say, upwards around, say, 750 gigahertz all the way up to the 25 plus terahertz region. That's the magical frequency range right there, where we can couple directly to the fundamental distance between the nuclei of an atom and its electron valence shell. And we can also couple at a lower frequency to the separation distance of covalent bonded atoms that are sharing electron shells. And with that, we can rip the electrons out, destabilize the material, and you end up with something quite akin to the Hutchinson effect.
Yes, and they call that the term for that is called the cycle stability. The charge stability, or no, the cycle stability. So you're trying to make sure all pulses of this every cycle is aligned, and that's the both signals interpreted onto each other. If you're just using all around a signal from one potential to another. So, these techniques do achieve that, what you just stated. And it just requires very slow, methodical tuning. It just by turning knob. If either on a frequency generator, that's pure analog. Digital is a terrible way to monitor anything. You're using digital settings, because between, like, if you look at digital integrated circuits, this is a basic intro to integrated circuits. You have, say, picture a rod, and the rod is segmented into 3 parts. So, you have two lines, one, in the middle at the top of the rod and the second line at the bottom, and there's a middle part. Well, the top part is considered, say, like the highest current will pass through that one rod at the top is like 3.0 volts to 5.0 volts, and 5.0 is the maximum. And at the third part, at the very bottom of the rod, is like, say, I would say like 1.8 volts to 0 volts. And between 3.0 volts and 1.8 volts is an undetermined zone that some of the electromagnetic energy, or I would say the electrostatic force, current passes through, that can either not be identified as a 1 or 0. It seems to be a part where the digital logic gates cannot differentiate between the current passing, and a lot of information is lost. That is why digital is pure garbage, in my opinion, and it is actually a subset of analog. Is where digital came from. So just to clarify that you were right, Jeremiah. I mean, yes, that's his extreme.
I mean, there's so much to this, and this is an area I study that could easily take up many decades of somebody's life. And in fact, thanks to the people who have given up decades of their life to look for these phenomena and quantify them and understand them, now we have those people to thank for these great books that will bring us into the future.
Oh yes, and it's very possible you can use a cell phone or a similar device to achieve the same results with the method you just mentioned. It's just between the two potentials, or the two input and the output, just by varying the different modulation fluctuations between those signals, you can achieve free energy, quote unquote, which. So, zero vector.
Exactly, zero vector waves. Canceling fields have a direct effect on time, and time has a direct effect on charge. Or I should say, relative charge. Because if you have a different rate flow of time located surrounding a large quantity of charge, and that's a varying rate flow of time, it's fluctuating more, slower and faster, it's going to appear to create an electric transmission or an electric field, and electric field is viewed from 90 degrees as a magnetic field, so you have real power there. But that power that you're getting out of that system has absolutely nothing to do with the conditions that you initially set it up with. So cause and effect here are quite separated by a number of degrees.
Yes.
Yeah, it's an open system, and so it doesn't violate any kind of conservation of energy or conservation of momentum requirements. It also doesn't violate the laws of thermodynamics, being able to draw more electrical power out of it, because again, this thing is an open system. It's just that where we draw the boundary lines for an open system, here we're talking about connecting directly with the dimension that kind of underlies our space-time. A more fundamental shape or structure to the universe that causes all the reactions that we see in all their angular relationships to emerge. That's why we see them everywhere from the planetary scale all the way down to the subatomic as above, so below.
Yes, if you picture it like an ocean where different parts of the space will be either hot or cold, is a perfect analogy of that. The Jason Verbelli actually has a book that matches the theory that we seems to be correct. It's called Escape from Einstein. I've been trying to get my hands on that
Escape
PDF.
from Einstein. I'm gonna look that up right now.
Yeah.
If you want the book called Gravity is a Push, I've got a copy of that one.
I would like that. Like say, gravity is just the effect of the Casimir force, or the repulsion and attraction of the fields. That's all gravity is. It's just an effect of that.
Push gravity explains the mechanism behind the Casimir force in a really direct way that applies to the Casimir force way better than our current model of gravitation, which is an attractive force, not a blocking force. So we also call that shadow gravity, or where you have a mass body, it effectively restricts the aether flow from the place where the mass is more so than it does from aether coming in from all other directions around. So just imagine that you have sort of a light source surrounding an object, and you have, or let's say you have lots of different light sources, completely symmetrical distributed light around a single light source.
Well, it's like the
Go ahead.
It's like the Somoluminescence project. I think that's the Sapphire project, right? The light that emitted into so hard punched into the vacuum.
Star in the jar you're talking about, right? And
Totally
like
different phenomena, but
supercavitation and all of that. And yeah, the Sapphire project has definitely done some good work on that.
Yeah.
And Forrester, feel free to join. I will post the link.
Jason Burbelli gave
Check it out. We got
the
Daniel joining in the
Oh,
audience
yeah.
now. So I suppose this is a perfect time to switch over, and I'll flip on my cam for a minute. So let's go ahead and show this. Okay,
A rare
so
glimpse of the top half of your head.
that's right. That's all I'm going to show today. So I will show you other things though above the top half of my head, and one of them is this grav inductor that I showed on BurnEye's show earlier. Now this is the previous interpretation that I had for the grav inductor. That is an invention of Daniel Foster, who's right there in the audience in the chat. And so I had twice the wire on these hemispheres than I was supposed to. And I wound with 2 conductors the entire length of 20 feet. So my pancake coils are 10 feet. These I wound with 2 different separate pieces of 20-foot each wire. Well, that actually wasn't correct. The hemisphere should have exactly half, exactly twice the copper mass and wire of the pancake coil. So here's what they actually are supposed to look like. This is the first layer of the hemisphere, and you can see that one of the 2 wires is stripped and the other wire is still insulated. Each of these wires is the same length, the stripped wire and the insulated wire. I wound them both at the same time. Then I peeled back the wire that I was going to strip, leaving that spacing between each of these points, which gives us a nice even distribution, and then proceeded to just simply insert that wire and hot glue it over 4 different hot glue lines here. Hot glue is obviously not the best material, but it's something that pretty much everybody can do. And the idea with this thing is anybody can build it. So this is what the first layer of the hemisphere looks like. The second layer is exactly like this. The only difference is it's wound in the opposite direction. So this hemisphere, we start out by coming from the center point down, and then we're going to follow that around. Let me see if I can get that aligned. Yeah, so we're going to start from the center point. I'll flip that around, easier to see, down, and then we're going to go clockwise all the way around. That's the first layer. The second layer, we're going to do the exact same thing as this, except for we're not going to strip the second wire, and we're going to wind it in the exact opposite direction. So when that's done, it looks like this. Now we have the inside of the hemisphere with our bare wire, and the outside of our hemisphere with 2 insulated wires, and the total length of the inside coils, bare and insulated together, and the total length of the outside coils, both insulated together, they are the exact same length. They're exactly 10 feet in my case. There's not a magical number with 10 feet. It just happened to be that my 100 millimeter sphere and the gauge of wire that I have turned out to be exactly 10 feet. So nice convenient number. Inside, you have pancake coils, and they look like this. So again, these pancake coils, I've beat them up quite a bit, and these are pretty much scrapped at this point. But just to kind of show you, because I've already wound these, you have 2 pancake coils. They're bifilar wound. So you're taking the end of one wire and connecting it to the beginning of the other. And you have 2 column coils. They're also bifilar wound. But instead of just 2 parallel conductors running the same direction, these coils here, the inside wire, the one that's insulated, that goes up in one direction, and the outside wire, it comes back down in the opposite direction. So at the cross points of each of those wires, you have a bunch of little crossing conductors all the way up, and you effectively have column coils which act like caduceus coils. Caduceus coils are particularly good at one thing above all else, and that's compressing time. Because you're canceling out some of your magnetic and your electric vector potentials. All canceled vector potentials end up with a temporal field to store that energy. There's no other way that it can be stored. There has to be a modification of the permeativity or permeability of space-time. It's the only way that you can change the intensity of a magnetic or electric field. It's a scalar potential. And so when you cancel scalar potentials, you end up with a rate flow of time change. It's actually pretty straightforward. In fact, it's so straightforward, it's shocking that we've missed it all along. Also, Bernie, you'll be excited. I showed you a text of this, but I've got one of these cobalt glass lenses, just like Mike from Faraday Research uses, claiming that you can see aether fields or auras through these things. Now, this is not actually the right material. Turns out those original Diocene glasses, they're made with a very hard to obtain chemical, and this is just a plain cobalt glass lens pulled from railroad signaling. But cobalt has very interesting and unique properties as well, and can be quite useful for gravitational and energetic research. So it's nice to have picked these up. They were really cheap. It's like I think I paid $5 for this alone. I got 2 lenses, so I got this one and I got an amber lens, $10 in total. But,
I also have do you have silver neobate? It's very good for capturing light and sensors, especially with
let's see.
lasers. With lasers, it actually amplifies lasers wave cohesion. From what I've been
I'm not
reading,
familiar with it doing that. I have silver activated zinc sulfide, which is
that might work.
scintillation material. It can detect or it can pick up alpha emissions, which are just really fast-moving electrons, and turn them into blue light.
Oh, there you go. That might work. So Steve, I was reading about the uses of silver neobate. So I was curious because they're used very much in laser optics and engineering. So
I don't have any yet, but it's definitely going to be on my list now to pick some up.
I managed to. It's not very expensive. It's like only like $5. You can get it online.
No, well, then I definitely have to get some.
I would have to send you some articles on it. You can even look it up. Uses of silver neobate on laser optics and what's like enhancement uses and stuff. So I was just curious because I managed to get my hands on some for free. Somebody was throwing about a bunch of medical supplies and they had it. It also has medical applications as well, but I have yet to look into that since that's my main field of interest.
Well, if you wouldn't mind doing me that favor of sending an email or a text or something with a link to wherever you got it for such a cheap price, I will definitely pick some up. Okay. It's a shame we can't get Dan on. His phone's all been hacked to heck. All of his devices have systematically, one by one, taken down. He's in the process of resetting, but it'll only be a matter of time before he can take that thing down too.
Well, you won't be able to censor everything, especially if there's innovation in ways.
They're attacking our tech directly instead of trying to shut down all the streams, which Bernie already knows. I mean, geez, Mike from Space, myself, and Gerald all went on a stream, and Gerald and I must have gotten cut, I don't know, 10 times or more.
But yeah, that was ridiculous.
Well, I only have a functional phone because I have a new phone. Like all the old ones, all my computer, everything else is all hacked.
Yes, that's why it would be best to create excess contact group emails or new emails just in case that everybody has a list, and backups, just on paper or whatever,
Absolutely. And I'm also going to be developing a Discord and Rumble community a lot more going forward here.
Oh yes, we could get some new innovative thinkers and as individuals that have yet to be encountered. That'd be definitely very interesting.
You brought up a lot of really good papers and references today. I'm quite looking forward to going over those and seeing what I can learn.
Oh yes, like you said, I think your thing is still exotic propulsion, right?
Yeah, that's right.
Okay, I had sent you something earlier. I need something on the dot product.
I never did get back to you. I'm sorry. I got to send you all of Richard Van Derk's work on complex electric fields and the difference between dot product and cross product.
Yes. My email will have the patent that you're looking for about the harmonic analysis that heals it helps you. Just say that. The medical advice is purely for entertainment purposes. It's free.
The toughest part is finding time for it all. Finding time to review these documents. If you really want to get something that's heavy on the terminology, you got to have the time and sort of the peace of mind in the environment to sit down and thoroughly analyze that stuff. I've just been struggling to try and find time. Well, Dan Foster and I have been busting our butts trying to see if we can pull some impossible miracle off in the next 9 days by showing something truly fantastic. And I'm working on a full tutorial on how to build that device. I just kind of briefly skimmed through. I just wanted to correct my previous error on Bernie's channel on hemispheres. So I'm going to show you that the hemisphere, each wire length is the same as the pancake coils, and then you have 2 stacks of those. So you end up with double the copper mass because you have 2 different coils stacked on top of each other. So that's critical. You have twice the wire on the hemispheres as you have on the pancake, and the pancakes have twice the wire of the column coils. So as you can see, you got a nice harmonic ratio set up here at 4:1 ratio. And if you've studied scalar resonance, those harmonic nodes mean quite a lot when it comes down to the copper mass and the dynamic nuclear precession of all those individual nuclei. The way they couple is significant.
Yes.
So, Jeremiah, if that's right, it means I'm pretty sure I wrote down our earlier conversation wrong about how much wire for each one of those coils.
Well, no worries, because I am working on a full tutorial video that will explain all of that.
Okay.
As an interest, have you ever tried wounding your coils into like a spiral, very tightly packed?
Give me about 20 seconds because I'm putting the battery on the charger here, and then I will show you exactly that.
Okay.
Sounds like he's on the other side of the room.
Yes, he is.
I have made a fair amount of coils and different ideas and things, but the whole 90 degrees to the previous reality, that's the one that Wilbert Smith really caught me off guard with, and I've never really recovered from that idea. I built all kinds of crazy things with that 90 degrees to our next reality thing.
Oh, that's interesting. Well, I have this PDF. I got a PDF I'm trying to find that talks about how to like actually analyze the standing waves that come off a coil, how it's wounded to like like a very slow way to to like literally determine the measurement length of how much the waves reflect or not reflect, but come off the coil, like the inverse square law, like the distance of the wavelength determines how much the magnetic field extends out to it of the coil winding.
I know antenna design very well. I've been a ham radio operator since I was in high school. And typically the shorter the antenna, the higher the frequency.
Yes.
Right. So when you look at this other resonance stuff, the stuff that Tesla had talked about, it has to do with the mass of the copper involved in the coil. And apparently that's not the opposite, like the frequency versus length. It turns out it's the other direction, and this has been something entirely new for me to deal with because it doesn't relate to anything I've ever been taught before, but it appears to apply, and it's weird as heck.
So like the mass, the weight of the copper?
Right, the weight of the copper on the primary and the secondary, you want them to link in these alternate energy worlds. That has to match.
Well, that's material science. That depends on the crystalline structure.
That's beyond material science, actually. What we're talking about here is a different type of resonance. It's not electromagnetic resonance. Can't emphasize that enough. Everything that you know about antenna physics goes out the window when you talk about scalar resonance and spin waves. It has nothing
Oh.
to do with the electromagnetic resonance, and all those calculations don't serve here. Because here we're talking about transferring the precession of a nuclear spin or an electron valence spin and its magnetic moment, and we're transferring that to the next one over. And now you have these spin waves, or waves of propagating, precession, tilt around the axes. So we all know how Earth has a bit of a precession. It's not its North Pole magnetically is not exactly where its geometric rotational North Pole is. And we also know that the whole entire thing wobbles like the top about to fall over. That wobbling, that's what we call precession. That same wobbling motion for a charged particle can be transferred to other charged particles to make them wobble just the same. And they'll all try to align their wobble along the same axis. So whichever way that wobble is pointing, all the other ones will try to align with that exact same center axis. That is called a spin wave, and it propagates at a finite velocity, just like a normal, ordinary light wave does. But what's interesting about that is the finite velocity is not velocity c. It can be faster or slower, and it's based on the total copper mass or the total conductor mass, or even dielectric mass, plain old material mass of these various materials that are coupling to each other. Because here we're not talking about electromagnetic waves coupling like an antenna to an antenna. We're talking about physical atomic spins coupling to each other, and the actual mass matters because it's a quantity of spins.
Okay. Oh,
but your Coils question, yeah. So here's one. This is based off a NASA thruster. This is a counterwound pancake, spiral pancake. Both sides are crossing, so we effectively have an outwards caduceus where our cross points are going to generate a very strong dielectric field facing toward the outside edges of this thing, and they're going to produce a very strong magnetic field coming off the face, top and bottom. And that's exactly what we get with this coil. When I power this up, I put this on an oscillator. What ends up happening is I get a column-like field that comes straight off this thing and slowly kind of thins out. If I stick a compass anywhere over the face here, it's going to tilt that needle instantly. If I stick a compass anywhere near the edge, it doesn't read anything. There's virtually no edge field on this coil. We also have really tightly packed coils, as you were asking, like this particular 1 megahertz bifilar aluminum wire coil. And I've also got some that aren't so tightly packed for higher frequencies, like this one that's 11.9 megahertz, another bifilar coil. Just got tons and tons of these, but each one of these things has a slightly different property. And this one is made of, let's see, what is this? 16 gauge aluminum wire. Now, I connected one of these two output leads. One of these is an input, one of these is an output, doesn't matter which, they're reversible. I connected one of these two wires, these bare ones, to the output of a 30 gauge Tesla coil, 30 gauge wire. And so that wire, in terms of what it can handle for current, is many, many times less than this aluminum wire can handle. But that secondary coil made of 30 gauge hairpin wire did not get hot, did not even get warm. This coil, on the other hand, got quite warm and was able to float a small piece of foil above it, push it away. So how did this aluminum coil made of wire that can take at least 5 times or more of the same current possibly get hot? That would be your dynamic resonance. There you're talking, once again, spin waves, because you have more motion going on the atomic structure with a coil like this than you have in the electromagnetic fields that surround it. You can't pick it up with conventional equipment, but you can pick it up just by, well, placing your hand near it, feeling the heat coming off, measuring it with a thermometer in this case. And you can also pick it up by having another matched coil just like the one you're transmitting through, and it will perfectly tune in. Once they're tuned in, you can separate them by a pretty large distance, way larger than EM would promote or allow you to separate, and you can still get an extremely high efficiency energy transfer, upwards of 95%. So there are many different types of radiated field, and they're not all classically electromagnetic. In the same case of Dan's coils here, where I mentioned his column coils are like a caduceus. To see that better, this is an actual caduceus coil. Here we have a true 90 degrees crossing, though my camera is kind of skewing it. If I just hold it straight up, we should be able to see that that 90 degrees cross point here. And so the angle of those two wires, I know it's being stretched out for some reason, but yeah, the angle of those two wires is going to create a canceling field along one vector axis, but it's going to create an amplified compression along the other. And these types of coils are well known to have really, really strange effects on watches, and can even transmit a laser beam-like signal if you can get them working correctly.
Wow, that's impressive. Well, that answers my question. So that definitely, I need to look at that book. But I will send those files to you. That should help out, hopefully. All right, I'll be on mute.
For anyone trying to design a caduceus coil, I don't know if you care about this, is that
Oh yeah, man, this is all about coils. Do tell.
anyway, the whole idea is that you apparently need a hollow core ferrite, and then these are two identical pairs that I made. Forget that other coil. Anyway, so this was very carefully picked. This took me months of calculations to figure out. I don't know why it took me months, but apparently it was mostly based in fear of getting it wrong and not knowing the numbers. Like, how fast does the propagation happen inside of a ferrite core? I believe this is number 43 ferrite core. Anyway, I've got like 100 of these things because I bought a pack of 100 of them. Grab a hold of it right now. Anyway, so I made a couple of them, and I've put a lot of power into these things, and they are really weird. They're glued together with a hot glue gun, as you can probably see, mostly because they didn't hold together very well on their own. But this is not like randomly wired. I went through my entire wire stash, and I found one that was exactly the right length, or I mean the right diameter. And turns out it was it's got a really narrow Teflon insulation. This stuff, I don't know how expensive it is, but apparently I couldn't afford to buy a roll of it right now if I wanted to. But anyway, if I put 100 watts of radio frequency energy into this tiny little thing, they don't even heat up. Supposedly, if I put a kilowatt into it, they're not going to heat up either. If I put 50 watts or so into them, they will heat up like crazy.
And
anyway,
just for reference, I've used those same size cores, Adam, and I can tell you for sure that I've made those things crack at less than 10 watts input. So conventionally, that ferrite, taking that amount of RF power at such a high frequency, it would never handle it. It would heat up, and it would eventually shatter itself or become so warm that it no longer had its correct magnetic properties, and it could even melt the wire. But in your case, you're not seeing that at all because the energy is being pumped in, but it must be going somewhere else.
Well, yeah, that's the whole thing. If you read Wilbert Smith's stuff, he talks about it going somewhere else. He talks about it as like a radio laser beam, and well, apparently that's exactly what happens. And anyway, they're an interesting little thing that, what do you do with this sort of thing? I've got a couple of them. I've played with it. He claims they've got no mass for the signal, therefore your mind can control where the signal goes, but he also said it takes 10 years of practice. I suppose if I had taken that at face value and figured out the practice regime, I would have mastered it 10 years ago. So, I don't know, these are 20 years old coils. So, I don't know. Anyway, it's I suppose it's like ball lightning. Apparently that stuff has like people focus and concentrate on it. It moves wherever they want. So, what the heck do you make of that sort of thing? There's some sort of interaction with reality there somewhere. But that's a caduceus coil. You saw Jeremiah's. These are the ones wound on a ferrite core, so they're going to be closer together. The whole idea and how you engineer these things is you want each coil crossing, which you can see here, hopefully, you want the speed of light in the middle of that ferrite to be the next crossing of the coil. So you just do the simple math on how fast the speed of light for a ferrite ends up working. And turns out these numbers are like not normally known. Like nobody cares about this stuff. So they're really hard to find. But anyway, with enough math and dedication and weeks of work, you might figure it out like I did. Either that or I'll just mail you, one of these cores for anybody that wants one.
Actually, turns out you can get those for stupidly cheap on Amazon or eBay. You can get like 20 of them for less than I think it's like $9. So.
I think I bought 100 of them for something like $20, but there's this weird Teflon coated wire I've got that made the distance right. I'm sorry, next to my stove is so broken. I haven't cleaned it very often, but anyway, this distance was extremely well calculated. And I don't think most people really think about, like, most people have calculated that out. I don't think they do the math. I've shown that to a bunch of people, and they think I just wound these coils for nothing. Anyway, you really have to calculate out the math of what's the speed of light, when does it get to the next turn, because that's really your calculation. It's how fast does the speed of light get to the next turn. So go ahead and show your coil you made with the speed of light being, without a magnetic core.
Right, yeah, that's one of the bigger differences. When I'm dealing with caduceus type coils, I'm primarily focused on, and as you can see, it's totally hollow down the center. So I don't use any kind of ferromagnetic elements in my caduceus coils because I'm really trying to affect the vacuum itself, not necessarily get a resonant effect within a material. That's a huge disadvantage. You have, well, in this case, compared to the ferrites you're using, about 180,000 times minimum less permeability for the vacuum than you do for a ferrite. Here's another variation of a caduceus coil. Here I've actually got 4 wires that are wrapped back and forth. So, well, it's technically just the two wires.
How do we zoom to your signal and not my broken one?
What's that?
Apparently, anyway, on my screen at least, it has me highlighted, but you're a tiny little square. How do we make you go to the full size?
Bernie would have to come back.
Oh, okay.
Yeah, I just now realized nobody could see either of those things because his icon is actually over where my name is. So that was kind of a waste. I'll show it again when he comes back.
Well, can you vanish your icon? I don't have icon.
I have
here.
no control over the stream at all. Bernie's got to change who's highlighted.
Oh,
right
okay.
now.
Well, we can see things slightly to the left of that icon. At least I can see like a 1/4 by 3/8 inch or something. Anyway,
we'll wait for him to come back, and I'll just throw it up on cam again.
Okay. But the whole idea of engineering that sort of thing, I remember telling somebody what I had done, and I had no idea that people just sort of built these things and there was no engineering involved. I was really surprised because I wouldn't build something without engineering it first. I better know what's going on, anyway, I guess that's just me.
Well, the great thing about some of this tech is, even though it's really, really specific in terms of matching one coil to the other, it's not complicated. You just have to measure exact harmonics of length. So you can have the same length, you can have half the length, you can have 1/4 of the length, you can have twice the length. But as long as you're using the same gauge of conductors, you're still going to end up getting that coupling coefficient. You just will end up translating a half spin into a full spin or a half spin into a 1/4 spin.
Oh, I completely agree. And I've read enough documents about how people make wire. The wire's like magic. I don't think most people realize just how hard that is to actually build.
Yeah, if our society went down, man.
So bang on with everything you guys are saying right now.
Yeah, well, now that you're back and hopefully the burn problem was good. This was the one we wanted you to show full screen. This is just another variation.
Oh yeah,
yeah. Coil.
Booyah! That's a key part of it, 100%. Jeremiah.
And so here we've just taken the 2 conductors. It's just made of one single long length of wire. But I took a piece of speaker wire, which is 2 conductors, and exactly at that center point, I soldered them together. So yeah, here we go. Right down there, you can see that solder connection just beneath the bamboo peg. That's where they connect. And so they start from this point, they wind all the way around, come back on each other, and you end up with a set of these aligned axes where you have a temporal propagation coming out in sort of a planar wave on the side like this, and you end up with your emission coming out like a laser beam from the end of this thing. This is once again another air core hollow caduceus. Many ways to make these things. This one, not too great. Plastic insulated wire is garbage for caduceus coils, just an FYI. Teflon works very well.
How in the world did I end up with a Teflon roll accidentally? And
Because
they
it used
ended
to
up.
be that manufacturers gave a crap, and if you worked for a company that used quality conductors, they probably used Teflon.
Yeah. Anyway, you work out the math of how fast speed of light. Anyway, now that I've got. Anyway, it's just weird that it works out so well with various coated wire. But anyway, it's a fascinating realm of experimentation.
Yeah, and then there's the other side of this equation, which, again, is totally not talked about. That is, depending on the metal of the conductor that you're using, or in the case of graphene or CNT wire, it's not metal at all. You get totally different electromagnetic properties from a wire, and it's not a resistance phenomenon. It's an electron drift velocity phenomenon. Remember, in carbon, you have all kinds of little scattered moments, but in graphene, where you have a continuous chain or a nanotube, electrons will flow around the outside or the inside, but not through or between the atoms, and they will flow at 42 billion times the velocity of copper. You think that might make a little bit of difference relativistically in how the fields are experienced?
Yeah, like, yes, you're so like bang on key to it. And these alloys, and like including things like bismuth, aluminum, probably now like even like if we can get neodymium and stuff like that into these alloys, and the monoatomics, like mix it in some gold, silver, mercury, it'll be intense and crazy and insane.
Yeah, material properties are absolutely critical, and again, it can't be defeated as right. This is a material science phenomena to some extent, but at the same time, it's also an aether phenomena where the materials are just acting upon the vacuum, and that's where our advantage is coming in. Bismuth happens to be a fantastic material, not just because it's one of the most diamagnetic materials that we know of, but also because if you arrange the crystalline lattice and you force it to become aligned along a certain electric axes, I have a patent that talks about how to make very, very fine conductor bismuth wire, and it exhibits near superconductor properties at room temperature, no cryogenics required. It's many times more conductive than copper, but only if all the crystalline matrices are completely aligned and it's a single crystal. Bismuth tends to form tons and tons of different little domains, and they never quite line up. But if you have a current passing through a liquid bismuth that's been melted, as it cools, that current will align those domains, and you'll end up with a single crystalline lattice through the entire bulk mass. And you can get crazy good conductive properties out of it. Man, I love the visuals, Adam. You're right on par.
How in the world are you gonna make a wire out of this stuff? Like, I've tried to crush it or bend it, like it's so fragile and just it breaks apart at nothing flat.
I swear it's a magical electrolysis, alchemical geopolymer style technology of mixing that is how the ancients did it, and the key to this breakthrough technology in metallurgy.
I've been wanting to make a bismuth extruder for forever, Adam. I've looked up to see if anybody else has done it. I couldn't find a single reference, not one single reference of anybody who just simply took hot bismuth in something that could take it and squeezed it through some kind of little orifice into a cooling fluid like oil that was already, just a little bit lower temperature. Not so cold that you would instantly crack it, but just a little lower temperature, below the melting point. I haven't seen anybody try it. I haven't seen anybody attempt to do it. You can't find any papers or documents on it. But it doesn't seem that hard, right?
So I mean, I lost the first pound of this stuff I had. It's somewhere in storage. If it ever gets expensive, I guess I'll go look for that a lot more. But like, what really gets me about this stuff is once you form it, it is so insanely brittle. Like, I can crush this, I can kind of move it around, but it's so brittle. Like, if you could make a wire out of it, you can never bend it, or it would just break.
It's only brittle. No, it's only brittle because you have lots of individual separate crystal formation or nucleation points, and they're all randomly distributed. When you force an electric current through it, you don't have all those individual nucleation points. They all align, and you have a single crystalline matrices. As a result, you end up with a very flexible and extremely conductive material that acts much better than copper. But manufacturing it requires an artificial injection of an electric potential, a current flow through that stuff as it's liquid forming into the wire. That's the key in order to get that flexible wire.
So I've got this little chunk here, and I've got a 225 amp welder outside.
You'll keep it liquid if you do that. You've got to have just enough current so it can cool down.
Well, I suppose. Okay, well, that'll be something interesting to try.
The way they had done it in that patent that I'm referring to with this making near superconductive bismuth nanowire, they used what was it? They had a liquid pool of bismuth in the bottom of a container that was on the top of that container covered in silicone oil, which has a melting temperature or has a vaporization temperature much higher than the melting temperature of bismuth. So it would prevent it from oxidizing. They took 2 electrodes, brought them very, very close together, and dipped them into the bismuth pool underneath. Then they stretched them out from that bismuth pool so they had a little bead between these 2 conductors, just like a water bridge using high voltage. And then they stretched those 2 electrodes apart into this, through the silicone oil, which was just below the melting point. And at some point, when they stretched it out far enough, they held it in place, dropped the silicone oil's temperature, and they ended up with the bismuth wire. Now, they didn't do this as a continuous manufacturing process to produce long lengths. They produced lengths maybe, say, a foot or 2 long at max, because that was the size of their physical bath. But you could still theoretically set this up for a manufacturing process where you could produce continuous long lengths and keep them continuously aligned by having, say, rollers touching the cooled down material and still injecting the current to keep it flowing. It's just that no one's done it. If they had, bismuth wouldn't be a cheap element, considering its rarity. It would be ranked up there with platinum and gold.
Well,
there's not a lot of bismuth on Earth.
I suppose I'm really happy I got like a pound of it, because and I've still got a pound of it I lost a while ago. I don't know. I suppose that's what happens when someone else has a key to your storage shed. Yeah, I've got another pound somewhere else, but yeah, it's well, I'm not sure I have the proper vacuum chamber or the heating stuff or all the rest of that to pull it off. I'll try.
Silicone oil is actually cheap.
No, but it evaporates. I mean, I've used it before. It evaporates away like crazy. It's
You're talking about silicone lubricant, not silicone oil. Silicone oil is nothing close to that, and it doesn't evaporate. They use it in vacuum chamber systems because it's non-reactive and you can get it to a really high temperature and it doesn't evaporate or outgas.
You're completely right. I'm sorry. Anyway, I suppose it's late at night. My brain is like a bit broken, but you are absolutely correct. I'm sorry I got that wrong. And I think the center and the rear differential in my car, they have silicone oil in them explicitly for the friction of that. Now, I've bought replacements for those things, but I've never installed them because it's a total complete pain. But anyway, like, what the hell am I going to do with this $1,500 part for my car I'm never going to install? Apparently, I'm never going to do rally racing with it. But anyway, either way, it's yes, silicone oil. I almost forgot that. It's
not silicone, not silicone oil. It's the
right.
same.
No.
Similar, yeah.
Right. No, I'm very familiar with telling people of Silicon Valley is where they make all the chips. Silicon Valley is where they make all of the movies.
Oh, that's never gonna get old.
I mean, it's so many people that make that error, or they don't understand. Oh my god, like they haven't watched enough movies, or it's something different. I guess it's like a. I mean, I know I'm all dyslexic, so I get the whole. I don't get the difference between. What was it? The original radiation was supposed to be the nuclear. So instead of nuclear, it's however other people pronounce it. Anyway, it's
the way I found out, the way I finally was able to remember it is when we had our nuclear president, and he was gonna nuclear. That's what nuclear was. That's not the correct way to pronounce it. But if you consider nuclear like a threat, I'm gonna nuclear, and you consider nuclear, now it's new and clear. That's an easy way to remember it.
I don't know. I suppose I've read Madame Curie's book, which, oh my gosh, is that heartbreaking as heck. And I keep thinking of what we're probably on the.
You, me, and Gerald have all been. Oh man. Well, I guess I'll say anyways. Yeah, we've all been exposed to some really dangerous fields and didn't realize what we've done to ourselves until after the fact.
Yeah, right. And I learned about that from testimony experience from a couple of ex-military guys that talked to me and sent me their different works on coils, experiments, and frequencies, and warned me of like their own personal, like once they were retired, like backyard experiments with putting these frequencies through coils and the crazy different physical like field effects, and like both harmful as well as positive and like beneficial to the body depending on what you're doing, and that it's extremely like you have to be careful knowing what you're doing, and like just safety first, otherwise you can harm yourself extremely quickly without knowing what you're doing. And Bob Grenier also speaks on this quite in-depthly. Oh, nice. We got Adam back.
Yeah, excellent.
I disappeared on everyone. I'm sorry.
Oh, good.
Oh, it's perfectly all right. We were just kind of joking about how we've all managed to physically harm ourselves with playing around with these devices and not realize it until way after it was done.
Well, right. I was ranting about how Madame Curie managed to, kill herself and her husband and everyone else around her, probably all of her employees, which never got cataloged. And anyway, it's new fields. There are always something different, and it's gonna be something else. It's not like it's that safe, but I'm pretty sure everyone involved is hell. We probably all know the risks.
Now, that's exactly the problem, isn't it? We don't know the risks. We're trying to figure out
we know
exactly
they're
what
about.
they are.
We know they're probably approximately infinite.
Yeah, we know there are risks. I think we can all say that in confidence. There are a lot of risks, in fact.
Dear goodness, why am I giving everyone a picture of my kitchen? It's horribly dirty. Anyway, but yeah, there's probably real serious risks, and Jeremiah knows this, but I made this machine that I'm pretty sure destroyed my health for most of my life. These things are not even close to safe. Everyone else around me ran away from this thing. Literally, some of them as fast as they possibly could run away, which is a really weird thing if you've ever met like anyone ever. Like humans normally don't run at full tilt for like minutes on end to get away from a device you built. But anyway, these things aren't safe. I'm pretty sure they're like really like Jeremiah's hover coil thing. I'm pretty sure that field's shape is like knives.
Yeah, that was a really, really bad idea. I don't know what the long-term reciprocations of that will be. I guess I'm glad I said one thing in that, which is I have no idea how safe this is. I'm at least glad I said that.
Oh, I'm pretty sure it's not safe at all. I'm pretty sure it's literally
you're right. It's not safe at all. I mean, that's been verified straight from the mouth of the inventor of that thing.
Right, but it's
Very,
literally
very
like
clear how dangerous they are, and he's got the burn marks to prove it.
well, I mean, I've got burn marks from my what's weird to me is like I've had a fair amount of burn marks. I mean, heck, I've grabbed a hold of exhaust manifolds on cars and stuff accidentally. But this burn mark from this the bagel coil field thing, it's still on my arm. It's it reminds me of like the abduction jerky. Have you ever looked at that website where you can get beef jerky from the abducted cattle? Because this started with like the farmers were like they were dumbfounded. What do we do with
You're
these
dead
things?
serious. That's a thing. That's really
What?
a thing. That's
Oh, no,
really
it's
a thing.
totally a thing. Go look it up right now. Go look up abduction jerky.
No,
It was a thing
way.
10 years ago. I don't know if it's a thing now. It was a thing 10 years ago for sure. Because I mean, what do you do? Like, what's a single cow worth? It's like $1,600. Something accidentally like picks it up, and they instead of dropping it on the ground, they accidentally leave it on top of the power lines. Like, what do you do with that? They were dumbfounded. They called the local police. The local police were like, we don't know what the hell to do with it. So anyway, they eventually formed this website. I thought it was a fantastic way of selling this stuff, but like no animals will ever touch that meat. And this reminds me of what the bagel coil field did to me because it's not even decaying. Like it's the weirdest damn scar I've ever had in my life.
No, it's not going to go away either. That's the problem with it.
Oh, it's not.
Go ahead.
It's not going away. It's really broken. Like it's not getting infected. Like bacteria won't even live there. What the hell does that mean?
Yeah, well, we all know what Bob said. These electron clusters can live in materials for years and years.
Right. Well, I sent Bob an email telling him what happened, and he came in his next video. He came out and said, "Yeah, we got researchers breaking themselves," and well, that was me. Anyway, yeah, these things are entirely not safe to be playing with. But still, I mean, they're magical, and they're the next thing in physics. They have to be played with, but they're not safe.
So it sounds like it's time to get a whole bunch of boron nitride paneling and stand pretty far away, because there is at least one safety measure that works universally no matter what materials you have or where you're at, and that is distance. Get the heck away from it.
So, remember that whole thing where I ran this machine and then the other half of the machine followed the cordless phone? Something
well, you took the other half of the machine with you, so let's just at least point that out. You were carrying a half of the machine with you in your arms.
Right. So something very, very, very important about these things that hit me days later is that apparently they followed me. When they were created, I was in the middle of the field. When they ended, I was right there. Every single last one of these things followed me to where I slept.
Really?
They took days to get to me. When you make one of these fields, when you make any of these fields, half of it sticks where you made it, the other half follows wherever you go, or the machine that made it, or they are sticky fields. They grab a hold of everything, and I think a lot of... Anyway, I've seen this personally, and I've seen this with all the spiritual stuff. It's really important.
You're also confirming like testimonies of people that I've like seen and worked with in the Keshi Foundation and their plasma fields that they've made out of these triple solid, like nano-coated solid coils. That it's just a lot of synchronicities.
Oh, at some point, it's so many synchronicities. It has to be something that's actually happening. And had I not seen, like literally like pocket watches, digital, analog, seeing them tick off time randomly in front of my
Mike from Clarity Research swears to having the exact same experiences with his M machines, as does Nassim Haramein with some of his plasma reactors, and so many more with these crazy freaking coil fields. Like,
if you're looking for people making stuff up versus people telling the truth, that's your big thing. Like, look for that, because there's no good reason to make this up, because nobody's going to believe you anyway. They all think you're whack-ass crazy if you tell them this. And it absolutely happens. I've seen it.
The amount of people I know who have seen this now and are working with these types of fields is greater than those who I have been told, no, that doesn't exist, and I play with this stuff. Very few people have actually gotten their hands dirty in the lab and not at least seen some emergence of the phenomena.
Okay, so here, this is a story that my own personal dad swears by to his life. Is like he was from a small like farmer town out in Saskatchewan, Canada, growing up, and that one day lightning hit the rail line, and a bunch of plasma ball lightning popped up, and that one of the orbs came along the rail line and then across the road and then through their front yard and actually came through the closed screen door of his house and like went like right up into like the main room, and like they saw it like all like while they were like in the living room, like watch it, listening to the one radio or the one TV or whatever the heck it was at that time, and like seeing it come through and like through the main window, like it all happened and whatnot, and then like it just like poof dissipated into nothing when it like paused after it paused in the main entranceway, is from what I was believe he tells. But I will get my dad to come verify the story one day for you guys.
Yeah, dude, you've got to record that ahead of time and at least play that session.
Yeah, I'll do that 100%.
The most fascinating part about ball lightning that I've heard so far, the most fascinating story at least, is the one that Bob tells about two different cases, two different incidences where ball lightning had apparently traveled through solid masses. In one case, it busted through glass and left a big old hole. And in the other case, I guess it just had gone through the wall or something like that and didn't leave any damage. But what's really weird is these ball lightnings, one of them collapsed in something like right after it entered somebody's house. I don't remember exactly where it was in the house, but it finally got destabilized and came pouring out of it a bunch of water that it had been carrying with it, almost a full volume. So what's really strange about that is this thing apparently was able to pass through solid mass, and then when it destabilized, it had a whole bunch of normal matter inside of it that seemingly wasn't affected or present whatsoever, didn't stop it from levitating around and whatnot. So I guess what he's really proposing here, these types of fields, when they are so tightly wrapped on each other, can physically isolate the interaction of any matter contained within ball lightning structure from interacting with matter outside that structure. And if you think about how flying craft might work, it sure makes a lot of sense. There's the other story, the second case incident was that thing broke apart, and I guess it dropped a bunch of sand, dry sand, that it must have picked up along the beach where lightning had struck. So how are these things carrying heavy elements like that, and the elements inside don't seem to be damaged, and somehow they're not like falling out or being burned up at that boundary layer where they must be resting against something with plasma? How is it that they are able to survive? In fact, how is it that you have a glowing, luminescent plasma, should be hot, that somehow doesn't boil the water inside that it's carrying? Again, we have no verifications for these stories, but I really, really would love to see that they were true. Because
I've got a couple of other stories from my grandmother, which she isn't alive anymore. And one of her best friends wrote a really fantastic book, but, I suppose that's, from a 106-year-old friend. Anyway, they were all in the living room of one of the buildings. I've got a couple of buildings south of me, and they were all sitting around the living room when a lightning hit the chimney, and it made ball lightning, and it left a mica window from this stove, and it literally floated between, I can't remember what it was, like 6 or 12 of these women in the middle. It floated right in the middle of that room and then blew apart right after that. Anyway, but that was something like 50 years ago.
And you know, it's I like that house. I really do want to move there, but it's just I've apparently filled it with a bunch of storage stuff, so maybe I can't move there. Although there's a bunch of rats and all that sort of other problems with it. Anyway, but the ball lightning literally floated between all these women that had this meeting, and this was years and years and years before modern physics ever admitted this was a thing. Because remember, when that happened, if you saw ball lightning, you were crazy. You had some sort of mental defect. It was
Ball
one of
lightning
those.
wasn't recognized at all. It didn't exist.
Well, it was recognized as a mental problem.
Yeah, just like those who see flying saucers. They're all nuts.
Right. Obviously, anyone that sees this sort of thing, they're obviously mentally unstable, right? It's just like earlier this evening. What the hell has been flying overhead all day? They are very, very loud, low flying, completely invisible. What the hell were these? Like, I don't know, 3 to 5 things flying into the Air Force Base. I don't know what the hell they were. I'm not sure I care, but it's really weird because generally I look up and I see the airplanes, but it's really weird to see something that is so loud. I mean, these things are devastatingly loud, and I can't spot them at all. So I don't know what's going on out there the last couple of days, but it's weird. Anyway, it's just like all the airplanes, the commercial jet airplanes. My mom loves them. Like when you say, what do you want to grow up to be? You know, my mom's going to raise her hand with, do you want to be a fire truck? She's going to be right there. It's really hilarious. But anyway, so every day in the garden, she wants to be a fire truck. She pays attention to all the airplanes, and it's just, I don't know, whatever it is. But there's odd stuff going on. I don't know if these people running the world are playing with this stuff. Do they care about it? Is something casually happening? I don't have any good data. Like, nobody else cares about this stuff. I mean, who sets up sensors for this kind of thing? Probably the people I'm talking with right now, but like, set up sensors. Go look for this stuff. How much is the Earth's magnetic field moving? How much electric field do you get for the appropriate return? Hopefully you don't have to move, because when I first thought about this stuff, I think I've moved 5 times since then. But if you get a place that's stable and you go look at this stuff, like go look at this stuff and make good records, because I don't know what's happened, but if I pay attention to spiritual things around me, something today in the middle of the world, something just happened. And I'm not sure what to make of that, other than maybe I should tell someone else this, but maybe not, because who the heck's going to believe me? Anyway, everybody else go ahead.
Bernie, what the heck are you trying to signal there?
I don't know. I'm just trying with the camera and the inverse, trying to like figure out how I position myself to signal to like the comments as I display them. But I've got it all backwards. So,
well, I mean, from my view, you were pointing.
But I was basically signaling. I just got to take a phone call and bathroom break. I'll be back in 5 minutes here. I want to share some Jason Verbelli stuff as well as some Bob Greenier before it's all said and done. But if you guys are continuing the conversation, I do not need to interrupt unless
I'd
you
say
all.
we pretty well covered most of it, at least.
Okay, so
it's not a bad session.
So this right here, when I was talking to Bob last, this is what he was saying we need to do. And I've been meaning to rewatch it. A simple, quick, and repeatable demonstration of LNR process.
Question is, how?
Oops. Sorry.
So,
there we go.
I remember that bit. He's trying to convince us all. It's not that hard, is it?
Isotope.
Yes.
And
oh, I know this part. This is great.
Very effective. We want a long-lived beta isotope to see anything occurring.
He must have been.
It had a low melting point that was very critical because we're going to be applying a Mars gas later on. and it was very soft. So I thought if there was any cavitation in the cavitation system,
should I play this for
that
a few
when
minutes?
the bubbles came out.
Like, should I play this for a few minutes, or did you guys want to keep what you're talking about going for a minute? Yeah.
I've seen it. I'm up for either direction.
Okay, you guys have seen it. Then let's do a little bit for. Oh, that's only 40 seconds. God damn it! I wanted to show some Jason Verbelli videos and presentations, but all the links that I had gotten are only to Twitter, and they turn out to be super short. But
I don't have Twitter because they won't allow my phone to be compromised by the Chinese government.
Yeah.
I agree with that.
I decided I didn't really care, and then TikTok banned me of all things. Like, I gained 2,000 followers in 2 months on TikTok, and they deleted my motherfucking account. So apparently the Chinese don't give two fucks about
So how many accounts of yours have been deleted so far? I mean, you got to hold a pretty good record.
I think I definitely do.
I've got a fascinating story for anyone that's interested in hearing. Someone that's supposed to be from the Ukraine, about 2015, and then this guy is asking me all kinds of technical details from a bunch of things. He supposedly lives in London, is disabled, and then he takes a screenshot of something earlier today and sends
earlier
it to
today
me.
That's happened.
What?
This happened earlier today.
Earlier today. Now, the thing is, he took a screenshot of it, and all of what I sent him is all in Chinese.
That's some weird ass shit, man.
So why is someone supposedly from the Ukraine asking me technical details on all this stuff?
Okay, I'm gonna let you keep talking about this while I quickly go take a piss and have a smoke.
Sounds totally fair.
I'm listening at the same time off my phone because, like, this is like what the fuck, and I really do want to hear it because I don't want to have the same sort of shit happening with me. And like, I'm getting different offers on like my emails and stuff. Like, supposedly, oh, we'll pay money to do these ads, this and that shit. And they're like, but you need to download and install a program. Like, fuck you, spyware motherfuckers. Anywho, continue.
You know you're onto something good when they cut your power, and
oh
that's
gosh,
usually a pretty good thing.
I mean, they're not gonna. Well, who's gonna cut my power? I mean, hell, if my lights go off, I've got battery solar. They can't cut the battery solar, probably.
If we're being honest, Adam, your lights are already off. I mean, you got to use a flashlight in your lab space at night. That's kind of crazy.
Well, I mean, there's no lights in the lab space because I've never put them in because, yeah, that's kind of a thing. Next of all, like, I'm worried about an EMP taking them out, which is why they're all an EMP. By the way, I finally got all of my EMP safe storage things in one spot. And the only thing that was really preventing me from doing that is that I had a separate room for all of my, I don't know, physics, chemistry work, whatever you call that. But then I had a closet that was filled with, I don't know what you'd call it, a bunch of, I don't know, cute, tiny bags. Like a whole shelf in the closet with that. Like, anyway, it's funny as heck because some of them are like anything from like purses I'm never going to ever use because I'm not socially allowed to use that, with like bags of like 22 ammo that I'm probably never going to use alternately. But anyway, it was just hilarious cleaning the whole thing out. But anyway, like I moved my oscilloscope to the hall closet, which should be a lot easier to get to. So, by the way,
on the subject, let's talk about EMP protection. If you have electronics that you give a darn about, a lot of people think that you can just wrap them in foil and they'll be fine. Well, let's at least dispel that myth right there.
Well, hold it. Let's say you wrap it in electrostatic-y, like aluminum foil. It's, go back to the original phrase, It's 3 letters, electromagnetic pulse. And so they shield against the first one, and somehow they think they're magically past the second one.
But then there's this wonderful material that mankind has refined over the years. They call it steel, and it turns out that it's both electrically conductive and magnetic.
Oh, it's a really bad electrical conductor and electric. It works really well. So I've got I don't know how many generators in the cargo container, but like it's a really good absorber of energy. Cargo containers are fantastic. You just don't want any bit of anything you put in them conducting to the floor. Now this one I've got is like half metal and half plywood, which I don't know if they had planned this or whatever, or how they built the thing. It was basically it's an instant garage. It was like $3,500, which is pretty darn fantastic for an instant garage.
What is an instant garage? Because I've not heard of that.
No, it's a cargo container.
40 foot. That way. I see.
Right, you just drop it off. You've got a garage. It happens in like what it should be like 20 minutes, but it took the driver. It took it way too long. He was not very experienced. I had figured the whole thing out of how he could pull in and pull out and all the rest of it, but no, he didn't do that. It took him something like 2 hours. He was asking me as a customer how to pull out of the whole thing. And my first thought was, dear God, like you should not be asking your customers how you remove your big diesel rig thing from here, because that's not like a thing. Anyway, but if you want an instant garage, like cargo containers, they're pretty fantastic. You just pay money and they just show up. Like it's pretty damn fast and they're pretty complete and they're made out of steel, which is a pretty good insulator. Now, the building I live in is made out of aluminum, which I'm not quite convinced is like the thing to shield against everything. But most of what I care about is in steel containers from IKEA. Are you familiar with
You're just
IKEA?
talking about the steel, the steel cabinets, right?
No, No, if I could tell you, go back in time, it would be go back in time and build these or go buy these 20 years ago. And like the most fantastic thing you're going to ever find is going to be the perfect box that fits into them. This I found yesterday.
Let's see.
So you need like a 20-year time travel-y thing to pull it off. But I'll, get you pictures or anyone else that cares. Oh, wait, I'm on full video. I forget that. Anyway, so, by the way, things like spears, they're not legal in California, apparently.
Spears are not legal in California?
Right, so if you've got like a double-edged spear, like this one pictured, it uses a handle, which I can't quite unscrew because, anyway. Yeah, if you buy it off Amazon, you get the, what do you call that, like the national average version, but anyway, whatever it is. I'm trying to clear space over this.
Laws in Cali suck.
Oh, California's kind of a mess, but when's the last time somebody told you, like, okay, fine, there's like couple of $100,000 of land I'd like to buy, and would you like to manage the property? So that's where I ended up. Anyway, so I've got these what do you call it? These containers. They are galvanized steel. They're from IKEA, and they've got a label on them.
Geez, it's really hard to see what's going on there on camera. Can you maybe? What are we looking at there, Adam? Can you zoom back a little bit so we can kind of see?
Can you? Well, hold on.
Oh, you're trying to get the brand name, the manufacturer information. Not until Bernie comes back, because he's gonna have to full screen you to get those details. So let's skip over that until he comes back. Let's just take a look at the ball thing, so kind of people have an idea what sort of containers you're talking about.
No, my whole point to any of this is that, if you trust the anything, you're probably wrong. Because if you don't have enough an EMP, I read like earlier today, Ken Shoulders thing about the EMP protection, and oh my gosh, if these weapons are real of the what Ken Shoulders talks about, like we're entirely in trouble. Like you can't trust transistors or any of it. Like my favorite flashlight here, you can't trust any of this stuff.
Now, I will
And
point this out though for anybody that's trying to protect sensitive electronic equipment. Say you have a backup hard drive or something like that. You want to store it somewhere.
Faraday cages.
So they're the cheapest. The cheapest thing I found as a fantastic EMP storage mechanism is an old file cabinet, which you can oftentimes get on the classified ads, Craigslist, that kind of stuff. They're relatively cheap. The only catch is you're going to have to go pick them up, or beg somebody to drop them off and give them a a tip for dropping this stuff off. But yeah, file cabinets work incredibly good. They're fairly thick, robust steel, and they will pretty effectively shield your electronics from an electromagnetic pulse.
I hope you're right, because here's like my first cabinet with that, and anyway, I hope it works.
Well, I stuck my crap in a file cabinet and ran it next to the impulse generator. That's 9,000 joules of energy there. Only 1.5 million amperes. It didn't hurt anything in the cabinet.
Well, that's good news.
Of course, I'm sure that the upper atmospheric burst is still going to be even worse, even more powerful than that.
Well, I mean,
shields against that.
Have you ever seen, like, listen to Ben? Who here listens to Ben Davidson?
I'm not sure I know that name.
Anyone? Suspicious Observer YouTube channel?
I'm not seeing any comments about that guy.
The magnetic reversal every 12,000 years we're up against, like in the near future. There is.
Okay, so he's the guy that came up with that, eh?
Well, at one point, I knew a lot of archaeologists, and they are very interesting people, and they're not very adventuresome, but they're very interesting. Anyway, pleistocenecoalition.org, I believe, is the website that is like those people. I remember that the guy that runs that website, his life was threatened at one point because he had that website. And I was asked to archive that website. They're pretty sure like they all forgot that I've been archiving that website for like the last 15 years. But anyway, it's one of those funny things. I tried to archive it earlier today, and the newsletter they have is fantastic. It's civilization is way more old than most people think it is. And it's one of those things, I mean, can you imagine a government telling their people every 12,000 years, your entire world is going to be torn apart bit by bit? Like, you're not allowed to own metal anymore. Like, it's literally like there's going to be some solar event that is not only going to rip apart
I don't know if they're all necessarily violent though, but what's going to be interesting is if we're truly in a white pulsar star now, and with the next supposed to be pole flip of the magnetic poles of the sun next year, and if it doesn't flip again and instead starts pulsing more, it'll confirm that we're no longer in a yellow sun solar cycle, but instead this new white pulsar star.
I am quite confident that's absolutely not the case, and our star has a long, long life. What we are doing, however, Bernie, is we fly not just around our own sun, but we also have that have the entire heliosphere, our local solar system, flying through the universe and flying through our spiral arm of the galaxy, right? So different parts of our spiral arm in orientation to where we are now have different field densities, and the constants can change. So as those constants are decreased, the amount of electromagnetic radiated energy increases by comparison to the ratio. And this causes some really, really interesting phenomena when it comes down to human psychology and our interactions, especially when we consider the extremely electrical nature of brainwaves and thought themselves.
This is the crazy lettuce that grew. It's finally sprouting, trying to go to seed, but I promise you it is actually a romaine lettuce that is no different than these ones, but had the monoatomic gold poured on it several
And you've
times.
already stripped the leaves off, right? Like that's why it's
Well, we literally ate 6 salads off of these leaves. That's what I'm saying. Like, you can't tell because we ate all of the romaine lettuce off of it.
But otherwise,
And
that thing was a
also-
huge bushy plant as it was growing.
And like that's the kale plant compared to like the surrounding kale plants.
So
Like,
you don't have chickens, right? Because chickens would have eaten all the kale as well.
no, I'm in a city. This is just our little backyard garden, and like you can see that lettuce grew to the same size as the sunflowers.
Yeah, that's by far the tallest stalk of lettuce I've ever seen. I mean, if I'm calling lettuce a stalk, we already have something weird going on.
So, wait, what part of the... You're obviously not around anywhere where I live on the West Coast. You have to be in the middle of the night somewhere.
I am in Calgary, Alberta, Canada. So Western Rockies, Northwestern Rockies.
Oh, goodness. Well, that's... You've got fences and all kinds of fancy stuff.
Oh, yeah.
Well, I don't have those things. I have a chicken's... Oh, wait, what's that? You've got a sign.
That's my clothing company and silk screening and vending and stuff that I also do.
Oh my gosh, well, you totally beat me because my whole idea in life is I'm just horribly poor, and that's not working out very well for me lately.
No, right? It's like you gotta project and work at making the dollars and the universe shall provide.
Yeah, we got to get a give money to Adam fund going on.
I actually read across something very different and odd. I think I might have an income stream, but like I'm not entirely sure. But anyway,
Look at how
great idea, man. Run with what we talked about. That opportunity that you got handed to you is a fantastic one, and you're more than qualified.
Oh yeah, no, I know exactly. So you've got little jars with coils in them.
Oh yeah. All sorts of triple solenoid coils and like combination cathodes of several different metal elements, and it's and they're in different states of reactions and like activations of the metals too, in like the alchemical state that Isaac Newton talks about, like getting them in crystalline state and the red active state, and then like with negative current going in, they start producing sulfur in the yellow sulfide state. And then whenever you have it's set up with right differentials, it starts bubbling and producing hydrogen all on its own.
Hey, Adam, I just point out Aaron. Aaron has been asking for a while now, several of us going on the coil shows. He's looking for some custom coils, and if I'm remembering who Aaron is correctly, I think he has some kind of a
Aaron's awesome.
And he needs some torsion field coils, and is willing to offer you the opportunity to make them for a profit.
Oh, so I have been meaning to make such coils. It's one of those things that I know I can make them with all of the copper wound around the inside core very, very accurately. But the problem is when you try to bend them, they don't bend. So anyway, I need to work on that a bit. I know exactly how to build all the hardware to pull this off.
So he specifies the parameters here. He's got 320 kilohertz input, roughly, variable, and he's only using a small signal generator, no other amplifiers. So your parameters are actually quite achievable. I guess what he's looking for is with the minimum signal input, he's looking for the maximum torsion twist. And that does sound like something you could easily produce for him. I don't have the time for it, but if you do, I mean, you guys should connect. I'd be glad to have you guys transfer emails.
Well, yeah, I mean, I suppose it says live 2 hours 46 minutes. Like, where's this going?
I've got another at least 15 minutes here I would like to show before things are all said and done. I remembered a couple of coil videos that are quite fascinating of a new channel I had just discovered recently. I'd really like you guys' input on this because it's really fascinating.
I'm all for that. Anyway, my email address is spacecase0, as you might expect. That would be spelled out with 0 being a character, and that's a Gmail account. And anyway, anyone, I suppose I'm so used to being filtered that I don't even know how to respond to anyone trying to contact me because that's just never happened before. But anyway, it's Spacecase0. My friends thought it was so hilarious that they wouldn't quit using it. So that was my email address from when Google first started giving email addresses.
Aaron wants your email address again.
Spacecase0.
Yeah, he's a real space case.
Zero.
Yeah, 0 is a like space and case. They're all spelled out. 0 is a number, not spelled out at all. That's at gmail.com.
Just post it in the private chat, and I can put it in the live chat if you want.
Yeah, I mean, I'm trying, but it's. Oh wait, does it work?
I pop it in the live chat, and then after Aaron grabs it, go ahead and copy that right away when you see it, and then you can delete it like a couple minutes later, so it's not sitting there for the bots to grab.
Yeah, for sure.
Oh, he's got it. He said he's got it.
Oh, very good, very good, even better.
Yeah, you it was you that showed me the flat Rodin coil style thing, yeah. Want a disc or something like that?
Oh, no, it worked. I think.
Yeah, show him some of that because those are technically torsion field coils still.
Anyway, so anyone that's got my actual phone number and wants it, I'm probably about a month or 2 months out from using my phone number and my phone service at all. So anyway, I've got a really narrow window here to talk with anyone else about any of that. Mostly because I don't know, I suppose basically poor. But I'm going to try to get a different phone number or a different phone service, but it's, I don't know. I suppose
so just as he says, just watch for his email to you, Adam. He's going to come from a Proton Mail address.
Email I can send and receive forever. If you want good contact with me, you're going to have email. No problem there at all. Oh, screwing in a light bulb into the middle of not a core. That's pretty fantastic.
You know, all the I don't want to call them star coils, but that's like the closest.
The PoE, those are the PoE Nunez coils, and he was showing Daniel Nunez's stuff there, which it's like, I think this is a rather short clip, so I'll replay it again with
what is that?
him speaking, because recently all of Daniel Nunez's videos have been taken down off of YouTube as well. So I've been trying to reach out to them and get a hold of him. I've talked to him before. He once came on Alien Scientist channel with us, but yeah, see what's going on. But this guy right here, maybe I'll unmute it and let him talk because it's quite fascinating. This guy, like the over unity he's saying, he's like, it's a 1.5 volt battery that he's powering this coil with, and then he's putting in and powering several different light bulbs within the field all at once, and it's all coming just from one little 1.5 volt light bulb going into the coil.
But
so maybe
how in the world does he do that? Because
I right there. So
that's not a 12 volt battery.
What? It's a 1.5 volts AA.
That wasn't a AA. That was a little 12 volt garage door opener battery.
All right.
Anyway,
I might be wrong on it, but let me here. How do you mind if I just like restart it and we'll listen?
Yeah, no, you can turn the audio on.
Yeah.
Yeah, leave your audio on.
It's
Here's my
300%
broken
over
coil.
unity. 300% over unity. I'm going to prove it. The simple reason why mine is more efficient is that, okay, it doesn't look as pretty as that one, but as long as it works. So, of course, there is no schematic. The video quality is pretty poor, but it's okay. That's not what it matters. It matters that we have free energy. Stop paying for your energy bill. Stop it. So, pretty quick, I'm going to go ahead and show you how the APEC coil and vortex mathematics is about. This is the coil. I'm powering everything with a 1.5 volt battery.
That ain't a 1.5 volt battery. I have those.
I made my little circuit with a power MOSFET and oscillator. No power supply. The only power supply, the only input is going to be my 1.5 volt battery. And this one has no energy in. There is no power supply for this one. So let's go ahead and check it out. And I show you, I can prove you we have free energy. Please watch it. All right. This is my APEC coil. This is my trigger. Call it trigger. I put this one under my coil. This is a power MOSFET. Everyone can build something like this. I will go ahead and put everything in the description and components. Everything is powered by 1.5 volt battery. And let's go ahead and check it out. The only difference between this one and the APEC coil from Rodin and Power and Nunez is that this one, first of all, it works on two different frequencies. It works on low frequency, no high frequency, and I can go ahead and prove it. And the result is this one. I'm pulling almost 12 volts out of this guy. Everything is powered by a 1.5 volt battery right there. I can go ahead and disassemble everything just like that and show you that there is really nothing hiding or anything. It's just by putting all this stuff together like that, suddenly you have that much voltage. So this one from 1.5 to 12 volts almost, that's over 300% or probably even more. So now the vortex here, obviously inside a tornado, as you well know, the air is pretty stable. So nothing, everything is spinning around here. I can tell, I can feel the heat with my hands. In fact, we're going to test it. We'll actually.
Oh, so you were essentially showing that it's he's getting 1 for 1 if it's not a 12 volts, it's 11
well,
and a half.
Let me answer two questions with that. First, let me address the most common problem I see with people who don't understand voltage and current. Okay, watts in versus watts out is power. You have to have volts and amps. If you can increase your voltage, but you decrease your current, it's not over unity. It doesn't matter how much voltage comes out. I have a coil that can run off 4 volts and produce over 1200 volts using a single transistor. No problem there. I have another coil that has an extreme ratio at about 2 volts. I can produce approximately 45,000 volts. That's a totally different scenario. But it's not over unity. It's just simply a voltage transformer. That's what transformers do. They convert a voltage to a different voltage by decreasing the current in the opposite direction. So anyways, what he's showing here is something called a 23A battery. And I guess I gotta start my cam here. Yeah, so this is a 23A battery, and right here on the package, I'll show you, it says 12 volts. These are highly recognizable batteries in this size, just by comparison to my hand, so you kind of see. There's not another battery that's 1.5 volts that is this size. This is the only one that takes this particular form factor. Compared to another battery that's the same diameter, this is a AAA. This AAA is a 1.5 volt, this one here. But anyways, he's not mentioning the watts in versus watts out, and that's really what matters here. Obviously, he's getting voltage amplification, but it's unfortunate that he's not understanding the basics of power. However, that doesn't make it invalid. This is still
actually, whether like all around here with a simple
Yeah, so it's
with
more
a
like
simple light bulb
one
here,
for one measurement.
we
That
can
way.
test
Just got
that
that wrong.
all around
Yeah.
here.
Well, what really
would
matters
be,
is
I can tell you the
if
spot.
he can power
Oh, there we go.
loads
That's the
with
one.
that coil,
So it
that
works on two
battery
different
could not
frequencies.
power.
You can tell
It's
that.
pretty impressive. And I'll tell you,
So
that
all in
bulb
the
takes a lot
center
of
right
power
there,
to light
because
up,
as soon
and
as you move
it's not
right
likely to
there,
come from that single battery.
so here there
That's
is
a
not
lot of
neutral,
extra
neutral,
transmitted power.
neutral, neutral, neutral.
Everyone's
All you
talking
have
over
to
the
do
top
is
of each
in the
other.
center right there. There we go. So that's what it is. That's what it is. So there you move it, and then this is my result. Check this. I fluctuate a little bit, but that's not a problem. We have over unity. We have free energy right there. I made it.
That's a Harbor Freight
It works on
voltmeter.
2 frequencies. Check this out. What do you know?
You cannot trust those things at
It
all.
works. We have free energy. It works. Check this out.
You can't use a Harbor Freight
right.
meter to prove that. I'm sorry.
I'm glad we're all in
So,
agreement. Like, you know, the truth,
that's what it
you
is.
know damn well from those little 23A batteries, Adam, they would
Nothing
have
is
a hard
hiding.
time, even with like
There are
a
no
snare
Tesla
connected
coils
to them to
around.
lit up that LED bulb. They have incredibly low current output. You put those things under a load, even with a garage door opener, hold that button down for 20 seconds, and that battery is basically going to be crapping out on you for at least 10 minutes until it has a chance to kind of recover.
What?
Well, that's what I'm saying. So, like this, like if some of these claims are real and like that light can remain powered in there, if that's all that's going in, that's quite the like feat. Like, is it not? Like,
I guess I would have to know more about who this guy is that's presenting this stuff. Because
I mean,
I'm gonna play another video too that's a bit different. I think
Otherwise, this one will even light a distance.
but
Well,
this
like,
is like
what
the concept and like
If there was any Tesla coil around in the
going
field,
wrong like you have, and to like also
you could
see
tell.
where they're actually discovering
Only when it gets
views
close to the center of it. There we go.
of like how is this counter space
Move it a
getting
little
that
bit,
extra
nothing.
energy?
All
yeah,
around,
even
nothing,
still,
just in the
if
center
that
of my
coil
coil.
only had 12 volts coming out of it, there's no way the EMF will be strong enough to
right
light that
there. There we
bulb
go.
whatsoever.
And that's how much
So
we have in here.
I'm suspect of it, really.
All right, you convinced
Exactly.
now?
But if it
So
turns
we
out
have free energy
to
here.
actually be something, then that's pretty huge, right?
Nothing is around.
The trouble
That's
I
my
have is I
Rodin
know of
and
coils that
vortex
can do
mathematics
exactly
right there.
that, and I
Check
have
that
some
out.
here. But that being
Check
said,
that
what
out.
I'm looking at here on screen doesn't
Check
seem
this out.
capable of producing that phenomenon.
1.5,
My big worry about all of this
11.6.
is it's a Harbor
volts.
Freight
That's
meter.
over unity right there.
Tick, so even if
Try
I
to beat this
recognize
one.
those
Beat it
things.
if you
No.
can.
They don't work. They
It's a
have no
scam.
resistance.
Hoax. It's a fake. Obviously. Every year, a new scam comes out. Every year. You guys are new to this, but these people have been doing this forever. Scamming nowadays, it's a full-time job, and it requires a lot of investment, marketing. That's how business works. The more money you put into marketing, the more money you get back from scamming people.
Oh, so
Let me tell you,
this actually isn't legit.
this is not the first device. Every year, a new device.
Well, voila.
Interesting.
Oh my god. Well,
This thing on?
Oh,
Hey, I want to show
very,
you something
very
real quick,
interesting.
but you're only going to.
In the video, they show they light 1,000 LEDs.
Right.
With 1 single watt of energy. That is very impressive. Let me show you one thing that works even better than that one. This is my over unity machine.
No, man.
Now I'm powering this system.
quit using Harbor Freight meters. They're
0.7
so
volt
inaccurate.
lithium batteries.
Well,
This one
after
it's a
knowing what
motor,
he's
and this one
really
it's a
up to and
motor
showing how
reverse,
much
so it's a
BS
generator.
people get tricked
1.5
into,
volts,
I'm actually okay
120
with him
volts.
using that Centec
Motor.
meter.
Check this out.
Because that's the same crap that he's
Yeah,
doing.
no, yeah.
All right, like
Actually, over unity. Check this out. I'm pulling over. Look how much voltage I'm making out of this. 25, 24, 27. Check this out.
That's not how a voltmeter works.
I take it back. He knows exactly what he's doing. He's fully aware as he's saying this stuff that it's BS, and he's intentionally
Didn't see
making
that
the
one
same
coming.
mistakes that they make just to highlight it. I actually like this guy now.
No, this is good. This is good to see. Right? All right.
No, keep on playing this, man. This is good for your audience. This is something that you need to show to Campbell because he has no idea how magnetics work at all. I've watched him do the same things. Unfortunately, he's seen too much of it.
Okay,
No
this
better.
one.
God, I have to figure out how to plug in my phone.
Well, actually, Adam, we probably shouldn't keep you any longer because I know you got to get to sleep.
Yeah, no doubt.
I mean, I've got to be up at sunrise.
We're going to close with this one, and I'm going to get your opinion on this one, good Jeremiah, as this is... That was good. That was good to see, actually. That was very good. Anywho, the point being, though, that there's... My interest is the counter space in between the coil. But this is something I believe completely different, and this has to do with collecting energy from the ground and harvesting
That
it.
is a thing you can do. And you can do it a lot.
Remember
yeah.
that 3 coil thing? I've been meaning to try that for like a year now.
Before I forget, I gotta mention, I took one of my small steel rings. It's 4 millimeters cross section, 4 millimeters diameter round, and the ring itself is, I believe, it's 110 millimeters diameter. Anyways, I put 3 coils on that, pumped them. I couldn't get a clean signal out of that thing to save my life. And the only resonance that I did end up getting out of it, let's see, it's still...
So did you see the I lost my flashlight somewhere. Did you see the video I sent earlier of my ring and where I've wrapped the coils around it? I had my multimeter, my oscilloscope down to like 20 millivolts per centimeter, and there's literally nothing here. Oh wait, I've got no. Anyway,
It's like it doesn't come through at all. It just disappears.
Right, so what we talked about earlier today, I've got nothing, but I know my magnetic coil is literally, people don't wrap magnetic coils in brass and copper because they don't work anymore, other than pure magnetic. So that wasn't an issue. But anyway,
What's crushing me is I can turn a compass with it, but it doesn't show up on the scope.
Right, that's exactly the whole point. Anyway, but I couldn't see anything on the scope at all, no signal whatsoever. That I know I lost my flashlight somewhere, but anyway, that didn't work. I need proper coils and a lot more things to make that bobbin coil, whatever you get exactly what that's called.
I'm thinking it's gonna, first off, it's got to be cast iron, or it's got to be raw iron, and the second thing is it's got to have a large enough cross section where you really do get the propagation delays. I was shocked because when I measured it, dude, I'm pushing almost
3 separate toroids around each other.
Well, we're talking about something a little different here. We're actually talking about flying saucer.
I'm trying to find a I found a flashlight. I'm sorry I lost mine earlier. So what I did was, anyway, the Magvid thing, anyone familiar with that? Anyway, I tried to build that, and here was anyway, I was curious what was going to go on with it. So I've got a large magnetic coil around the outside, and then I've got this coil here is hooked to my signal generator, and then I wrapped a couple of small coils around and channel 1 and 2 on my oscilloscope to see what in the world it did. But turns out I cannot check the propagation of speed between this coil and the other ones because, well, I don't get any signal at all. But I suppose I was interrupted with several things, including this live stream, which is pretty fantastic. But anyway, with the little machine I've got to wrap this into a coil is it leaves so many sharp edges, like it'll just tear your hands to pieces. So it's not really a safe thing to be touching afterward. But anyway, that's I was looking for the delay time between that and the
mostly the other two coils. So can anyone else set this up? Does anyone else have this sort of ability to do pretty easy? Because I put my oscilloscope on 5 millivolts per centimeter, and it didn't read anything whatsoever. So I think I need real coils on both of these points.
Well, I can tell you why you didn't read anything and why I read a bunch of noise. I did get some signal, but it was just such garbage, and that's why it was kind of worthless. I did get a signal. It's resonating. My little ring is resonating into like the 300 to 400 megahertz range. It's really way up there, and you wouldn't expect steel to do that, but it's acting just like a copper conductor at that frequency. It's not like
I've got plenty of hardware that operates there. If that's where I'm going to go be playing with, then I've got no problem running frequencies like that.
It's just weird, though. I didn't respond it all the way we thought it was going to. Surprised me.
Well, if it's 400 megahertz, that's I mean, that is kind of surprising, but you know, it's totally doable. Like that, that's not very hard. It's just weird.
It's just for steel. I would have expected, especially considering how tightly my coils are coupled, I would have expected a slower delay propagation, but it seems like that spin wave just shoots right through that thing as if it's nothing. In fact, it almost seems to move even faster than ordinary magnetization, which makes me wonder if I have to inject a field orthogonally to that thing in order to get a response.
I mean, well, yeah. I mean, looking at my setup here, I've got the what do you call that? This here, how to hold this and not block the camera. Anyway, I've got the steel rod here, and then I've got a huge coil. So the next thing I was going to do is go turn on the coil and see if it affects the steel rod. So, but anyway, I haven't got a chance to do that yet because, as you probably well know, I've been on the phone for like 8 hours now or something.
Yeah, from one to the next to live. So, and just to kind of compare, so this is the coil. This is the one that I use. Yes. Oh, I gotta start my cam, don't I? Yeah, there we go. Come on. There we go. Really, really simple. Basic chrome-plated steel ring. I've got 3 identical coils, and this was my setup. I did get a signal out of it. It was way faster. I slid this coil over here all the way around right next to the input coil, and what I ended up getting was 0 phase delay no matter where I put this other coil around the ring and slid it. Didn't matter. Same exact phase. Not a single bit of detectable delay down to 1 nanosecond. So that I don't get. In fact, something even stranger, when I cranked the power, the receiving coil over on the far side was preceding the waveform of the transmitting coil, and they came slightly into phase, maybe as much as 3% when I moved them right next to each other. But for some reason, when they're farther apart, it seems like the output coil leads the input coil. What the heck is going on there?
Remember that paperclip experiment with the antenna?
Which one?
Paperclip vanishing.
Oh, yeah, the paperclip experiment.
Right.
Absolutely. Yeah, we're still after that. In fact, it's the reason for why that thing exists.
Right. I'm just, when you ask that question, it reminds me that it might be because, well, something weird is going on.
Well, I can guarantee you something weird is going on, but the question is, what the heck is it?
I still think this whole entire realm is like figuring out chemistry. It's just as complex. It's just as messy. It's going to take a lot of people a bunch of time to figure this stuff out.
Yeah, this is a brand new area of science that absolutely hasn't been quantified or explored. In fact, I'm not even sure if it can be quantified because this is like the physics of all the variables.
Well, I mean, I've read chemistry books from the 1800s, and I've had copies of these things, and it's fascinating to read them. And
at a point they decided that they were all done with the alchemy people, and they made a clean break because they were apparently tired of these ideas, and I think they lost a lot. And it's
They
one of those.
intentionally suppressed it all.
Well, no, I mean, nothing's been suppressed, right? Like the medical information or any of the rest of this. Like, can you
Yeah, if
imagine?
you see it on the news or TV, it's all true. Nothing's suppressed. All that's conspiracy stuff. You're nuts. You're a wacko. And how could you possibly consider the data over what you're being told on TV?
Right.
And what do you think you are, an expert that can read and like analyze things on your own and think for yourself? Well, who are you kidding?
Oh my gosh, yeah, it's what in the world is that device?
Well, it's claiming to be some adaptation of the Don Smith generator.
Yeah, Don Smith generator. This is the channel that I really wanted to show you the work of that like is actually legit research, and it's like confirming a lot of what Mike's doing, and then like a bit more in depth on other aspects of it, and I was wanting your opinion on it. So I'm gonna restart this little
We gotta
video.
play this with audio too, and I will say this as a premise: Don Smith is legit. I don't know if this video is legit, but Don Smith absolutely is legit. I've got verification from about Don Smith from a Skunkworks guy. So
it's right. So this couldn't have worked out better. Debunking like the fake freaking YouTube video view scam videos to showing legit stuff and prospecting what we know as legit researchers like Don Smith stuff and seeing other people who are looking into the similar research.
I hope this video isn't another junk. But
bulb is being run from earth ground and literally just an antenna. So the antenna and earth ground go to a rectifier, and it runs this extremely bright bulb, which is giving off a lot of heat, by the way. Like more heat than it should.
Yeah, that's an LED filament bulb, and those usually don't.
So the next step is to get other earth grounds and get more of these. As you see, I'll move this away, and it will go out and get dim. It goes out. It's literally just a copper tube.
Why the delay time?
I was gonna wrap aluminum over it too to make it
because it's building up its own resonance, high Q, using its body as feedback. That is a really good sign. That's the same stuff that I see in my equipment. Same behavior. It builds up and then it hits some kind of a max.
Tune it. And click it on and well, bam! That's bright. Assuming even less power now. But god damn, that's bright.
Yeah.
Wow.
Not that
free energy. Don Smith wasn't lying. All we gotta do is self-loop it somehow. That puppy's giving off heat.
God.
Stay tuned. You can literally see how it's connected. Antenna. Earth ground. Earth ground. Antenna. Rectifier. Runs the load. It can't get any simpler. Like, it literally cannot get any simpler.
Oh, this guy's gonna get a subscriber.
It can get simpler.
Cables go to the conjugator coil. And this thing's giving off
Where's
heat.
the AC hook to the DC?
A lot of heat.
I'm gonna have to check this out and see some of the videos that he explains the setup.
Welcome to the great financial apocalypse. You're winning
more that I wanted to share with you because that's I was impressed watching his videos. I've only been following him for about a week now since he popped up in my feed. Energy Researcher is his channel. Make sure you have the notifications. And there was another one here that was I think this one with the antenna using the aluminum wall. This one,
That's sure not my channel.
Yeah, dude, ground pumping current
Version of
is
my
absolutely the best way to achieve stationary energy resources if you're going to do any of these kind of pumped fields.
I've
Yeah,
really
that's
wanted
what
to.
Faraday Mike like research always states too, right? And he's exploring the same guy's build. So just wanted to point that out.
So if you're looking for my opinion on electricity, I think we can't trust it at all. I think that anytime you have any sort of metal in your life, there is a solar event that can probably wipe it all out by lighting it on fire and melting it. And anyway, I know I'm an electrical engineer and pretty good at that sort of thing, but I'm still kind of half panicked at what the sun is probably capable of. And anyway, that's my take on things. I don't trust electricity at all.
Well, there is one single electrical device that I can think back in history we would probably all recognize, and I don't even know if you can kill it. If you didn't put it in any kind of metal cabinet and we got hit with a electromagnetic pulse, and that would be that freaking Nokia phone, the Indestructo phone.
Well, I mean, have you been watching Ben Davidson's channel? He's
No, I don't know.
recommending that people put their guns inside an EMP protection storage safe because it would melt them. And I'm like, do you understand that, like, if you can get anything through EMP protection, like, that's something. Like, he's not super technical. I suppose his background is all biomedical stuff. But anyway, it's hilarious. I don't think a lot
you're not
of people.
popping off bullets anytime soon unless you're going to.
This one right here is the one I wanted to show you guys. So it's pretty crazy, like the amount of like arcing going on in the bulbs when he holds them up here. That I'll put like, look at that.
It's a really nice E field for a fairly low amount of power.
I
really
found
nice.
I found my phone charger. I'm very happy.
Yeah.
It's
So,
150.
I'm gonna check this guy's channel out. I want to see what kind of he's on there.
I'm gonna mute myself out and just let him talk here with this video and get your guys' opinion on it.
I already
It's
like
getting crazy, guys. Like, wow. I'll turn it on and show you what it can do. Draws anywhere from 20 to 30 watts. All sorts of interesting phenomenon take place around it.
Thanks
Turn
for
my
live
light
for
off so
30
you can
watts.
see
That's a
this
really
even
good
better.
field.
Like, wow.
And he's got a wire connected to that terminal output. It's loaded.
I never built something so finely tuned before. And that's lit just from my ground wire. Look at this. And that's ignited too, the fluorescent.
Dude, that coil's got fantastic
Wow.
range. I gotta see his circuit.
And that's the power consumption. 15 times 1.2, so we're under 30 watts. And there it is.
That's cool. He's
And the
actually measuring
plasma,
the
the
input power
heat
to his
that
power
this plasma
supply.
generates in the light bulb is way more than 26 or 30 watts. Like, there's so many effects occurring here worth studying. Unlimited ground power extraction, plasma phenomenon. Like, it's crazy.
That's real Tesla tech right there.
Jeremiah, do you have any video or anything of that hover
Just grab this
coil
bulb,
inside
wireless
one of those?
lighting, like, insane.
I
never built something so finely tuned and perfect before. Wow.
Oh, I
Looks
gotta
like
get me one of
aliens entered
those.
the room with the green bulb.
What in the world's making green?
He's got a green LED bulb.
Good
I
old
didn't even know
rainbow
those existed, but I'm gonna get
titanium
one now.
sphere.
Oh, I've got a bunch
Wow.
of green LED bulbs. I
Everything is
figured it was
perfectly tuned. Notice how
fluorescent or
nothing
something.
dims.
Yeah, but having
It's all
those
about tuning.
thin LED strip
And their proper
filaments is
Tesla
way
coil
cooler.
is as wide as it is long. So a 4-inch coil, a 4-inch long coil should also be 4 inches wide.
He's right.
That way you get your magnetism equal to your dielectricity and you just get insane effects.
He's right.
Like, look at these light bulbs.
Yeah, this guy got
It's
my
consuming less than 30 watts of power. Like, that's a lot of activity for less than 30 watts of input power. And here's an even weirder effect.
What's this YouTube channel?
See if it'll occur. The whole light bulb will
Yeah,
glow
Bernie put it in the chat.
green. And I had space appear in a light bulb one time. What the heck? This thing is drawing long arcs.
Good experimentalist.
He's got a very
know if you can
nice
see that
design
that
there with an incredible range
There's
on
all
it.
sorts of weird effects. What the heck? It's heckling my finger. And it stopped. I think the... Oh, no, it's like here again.
At least he knows what he's doing, not like me that put away my bismuth and have no idea what the cardboard box I just set it on top of contains.
You'll find it when there's daylight.
Maybe. Probably.
Yeah, he
Those are all
has kind of an
vacuum
opposite
bulbs.
approach to the way I build them. I designed some coils to have incredibly high output current, which is kind of the
Wow.
opposite.
And I
but
haven't
they're all
even
pumping
messed with
coils.
ground power extraction on this beast yet.
The whole...
Holy shit.
The whole bottom layer of that's
blinding.
all tiled.
That is a great little coil.
Here's my input.
That's fantastic.
25 watts or 26. And that's my input. And I have extreme activity.
He doesn't know the frequency, does he?
You tell me this isn't worth investigating. Oh, there's some really weird effects there.
I gotta pop that open in a new tab.
I'll get the big fluorescent tubes. Wow. That is bright. Damn.
If you want to see something brighter, I've got a video up on the Exotic Propulsion channel.
I've got some ludicrously bright LED lights that have no business existing.
Look at all
but
that.
still they're fantastic.
All that for 25 watts.
That right there is like the arcing of the bulb.
I just can't believe
It's
how
the
effective that thing
materials
is
you
at
construct
transmitting
it
the
with,
electric
along
field.
with the principles that allow for such insane effects.
Pretty
It's full
fantastic.
Power.
I mean,
25 watt
he's got to
input,
be
you're getting
pushing
all this activity.
I know when he gets close to that thing,
insane.
obviously the coupling coefficient changes, but you know, say minus all
This
the surrounding
technology is
objects,
just
he could
scratching the
easily
surface.
push like 70 kV on that thing.
Damn. That is nuts.
I bet it's more than 7 kilovolts.
Yeah.
I'll show you how crazy
I'll find out. I'm going to replicate that
sparks
coil.
get when I bring the ground wire near it.
It's my coil. You try to do a ground arc like that, and it'll basically melt your wire.
Huh. The prettiest arcs I've ever pulled out of the wire are gold-plated wires, and oh my gosh, pull a little plasma arc with a
Notice
bunch of
everything gets
gold in
brighter
it.
when I
It
ground
is
it.
so pretty.
But yeah, stay tuned. More to come.
If you wanted my opinion on it, this guy definitely knows what he's up to. Oh, and I just seen as you were scrolling through his comments, several other people I'm subscribed to and know are also on his channel, so that's already a good sign. He knows what he's doing. He's taken some pretty good tests here and developing them. I'll be subscribing to that channel and checking out almost all of his content.
I will subscribe instantly if I can figure out who it is.
Well, like I said, Bernie posted the links to his channel in the chat, so it'll still be there tomorrow. If you want to compare that to like a really high 40-watt bulb test, a lot higher energy than he's running.
Last year I made 400.
Sounded like I heard someone say last year something, and then I didn't hear anything past that. Could you repeat that?
Oh, I was saying if you wanted to see a 40-watt bulb test under strong capacitive one-wire load, because here he's got 2 wires connected to everything except for the bulbs he's holding. Yeah, if you wanted to see a filament tungsten bulb get lit up with a huge amount of power via 1 wire, I got that up on the Exotic Propulsion channel.
I think this is the one I wanted to show. I'm trying to find one where he had a massive like antenna of aluminum foil going around between this coil, and then was getting so much more arcing and light off of it. It's the last one I want to show of this because it's pretty intense.
Yeah, this beats the living
As you see,
crap
I
out of this
disconnect
player
ground, it'll
exciter
get
stuff.
dim and nearly go out. I add ground, it gets brighter. And you can see this is ground. I'm touching the conjugator coil. It's resonating at about 500 kilohertz. I would like that to be a higher frequency, but it still seems okay. Still seems decent for ground power extraction. As you notice, this LED is lit up from an Arvamenko plug with 1 wire coming off the primary.
Heck yeah, buddy.
This separate LED is lit with a grounded antenna diode configuration. As you literally see, it's just an antenna diode configuration of 1N4148 connects to ground. As you see, I
Another 1
disconnect
wire.
ground, it'll get dim and nearly go out. I add
Dude,
ground,
that's nuts.
it gets brighter. And you can see this is ground. I'm touching it and not getting shocked or anything. This is a ground connection. So people in my earlier videos said that this was a hot line, that this is ground. This is not hot. This is an energy harvesting device that sucks power from the ground. Here's the antenna diode configuration. Circuit is consuming 24 watts. Input is 15 volts DC at 1.1 amps, consuming 24.3 watts. And very good wireless range. And we also have the ability to light LEDs between 2 separate ground points. And this effect produces no draw on the transmitter when you do this. So I think I'm succeeding in harvesting energy from the ground.
I would say.
And as you see, this yellow wire goes to a grounded connection. It's just regular ground. I'm touching it. Let's get a little dimmer. Ground connection between another ground connection back here. Unplug it, it'll go out. Unplug, it goes out. Plug it back in, it comes on. You got all that. So I'll show you the power draw. 24 watts, 24.1. I'll disconnect these bright LEDs and there won't be a change on power draw. No change on power draw. I'll plug the LEDs back in. And boom, they're plugged back in. No change. So that's a very interesting effect. And I'll show you the last interesting effect. An incandescent bulb will light with 1 wire in my hand off the primary coil. That's 1 wire. And that's still going, that's going, that's going. Bulb is building up heat. Notice that those do go out when the incandescent ignites. It must be detuning something somehow. I believe it's only going out due to detuning, not due to running the load. So.
Yeah. By the way, Adam's internet just died, so he just let me know. His internet company, he said, decided he should probably go to sleep.
Very interesting.
Actually, oh goodness.
There's an even cooler effect.
Yeah, the thing to finish it up with this one here.
But yeah, that's
one of my opinion, you got it. The guy is legit.
As
far as I can
see.
So
exactly. So
you can probably extract unlimited amounts of power through 2 separate ground points. And yeah, stay tuned. Much more to come.
The secret to growing your tool by 65% in a matter of weeks could be.
There we go. So yeah, figured that's a good way to pretty much wrap it up with things. Maybe do tonight. We got Charlie C on Leak Project. Myself, yourself. You're gonna be there absolutely, and going over the gravifier and all of that.
I've got some work to do tonight, but I should be good to go.
Perfect. And yeah, so we'll be like repping APEC and also going over some more of the LENR stuff. Like that stream with Jeremy earlier tonight was absolutely awesome info and knowledge that he knows on the LENR too, and just getting ready for the upcoming APEC in 2 Saturdays from now's time.
Yeah, it's coming up soon. It's on the 22nd.
The 22nd is next Saturday, I guess. Yeah.
Yeah, 9 days, I think. No, 14.
Beautiful. Beautiful indeed.
8 days now.
Exactly. So we will see you all tomorrow then. And unless you got any final things to say, Jeremiah, or
Not a good show tonight, man. I'm glad we got Adam on there. That was pretty awesome. Guess the other fellow wasn't quite ready to share what he had.
sure. I'm gonna I'll be doing another one with Frankie. I think he also wanted to go a little bit more onto the Antiquitech side and esoteric side of his research too, or something. And but yeah, it's awesome everything that is coming out, the sharing, the learning, the knowledge, and the developments, and our figuring out what is bunk and what is legitimate and what we're putting all our energy into and gonna make happen. And one day we will all be flying. And there's an interesting podcast I'm going to be doing with Paul Cook, and coming up with early 1900s, late 1800s dynamos, and using DC electrical energy for healing and for health purposes. That is also going to be fascinating. So
DCS. Well, I've got my own opinions on that one, but we'll see.
Exactly. I always love Jeremiah. Join the technicians and exotic propulsion. I guess I should probably show your channels before it's all said and done, because great.
Well, I don't really join the technicians channel anymore, but I'm still doing the exotic propulsion one. That's kind of the
I don't understand why. I think you should.
Because it's a different audience, man. The Join the Technicians channel is really, I guess it's more down to earth projects, but I'm really focused on the propulsion and gravity research now, so just don't have time to put together those fun little projects.
Well, I just posted Join the Technicians, the one that you just said you weren't doing so much anymore.
I'm leaving it up there. I mean, I'm leaving everything
so
alone.
You've got 13,500 subscribers on that one, and then we're gonna go to the exotic propulsion, the one he's actually doing stuff on, and make sure you go subscribe because there's only 165, and this is where he's active. And that's why I'm like, Jeremiah, you're neglecting your 13,000. Give him
Yeah,
everything.
I
Give him
know, but
everything.
I'm only neglecting those 13,500.
I get it.
Because I'm instead engaging with the entirety of the human species in some hope that we'll actually not die.
That is true. That is true. Because in this one, you can Join the Technicians, though, Jeremiah does awesome things like how to build your own wands that actually have charges and like electrical charges and like real physics behind cool practical things that you can do.
You know what kills me is I shut off ads on this channel.
And yet
I had turned them all off. It turned them all back on. It didn't give a damn. Google changed.
Yeah, so now you're not getting paid for those ads that clearly are still happening.
A penny. I've never gotten a single penny from YouTube advertising ever.
Right? Like, me neither. Hopefully that will change, though. Hopefully.
Well, I don't want money from YouTube ads, anyways. I just want them to stop sticking ads on my videos that I don't want my audience to have to go through. I was kind of proud of the fact that my channel didn't have any ads, and then they just turned them on anyway. So,
no doubt.
And I had to go through this whole rigmarole of getting certified and all that stuff just so I could have the option to shut off ads. And yeah, it didn't matter at all.
Didn't matter at all. The corporate fox. But at the same time, I love you, YouTube, and hopefully we will be able to make money off of you one day so you can support these great projects that we're doing. And on that note, we'll see you all tomorrow. Love you, Jeremiah. Thank you for everything you do.
You too, man.
For everyone in the chat, everything that all of you do.
We have a great audience. There's no doubt about that.
I couldn't agree more.
You, but devoted.
Thanks, brother. We will see you in the evening and let you get back to all of the crazy next level work you are doing in your lab on the continuation of Year of the Coils.
Thank you.